Very good morning, everyone. Welcome to yet another HSMA 6 session. Today is the second of our three Python tutorial sessions designed to introduce you to the basics of Python coding. So last week we covered a number of the kind of more fundamental aspects, things like printing output, getting input from the user, variables, working with variables, looking specifically at things like lists and dictionaries, conditional logic, loops, and a few other things. But this week we're going to look at a few more sort of core concepts, core sort of programming concepts, but also a lot of today we're going to be spending looking at two fundamental Python packages that are incredibly important if you are doing anything in modeling or data science, and that is NumPy and Pandas, both packages that come with the Anaconda scientific distribution of Python, and are widely used in data science. Indeed, these packages are two of the packages that you will use the most, I suspect, moving forward. And one of them can seem a bit less friendly than the other, but it is quite important. But hopefully you'll gradually get used to how these packages work. And as ever with all things Python related, this is all going to take time to bed in, so don't think that, again, you have to get to the end of this session and understand everything we've talked about. You don't. There'll be plenty of opportunity. You will see NumPy and Pandas in use, you'll see functions in use, you will see all of this kind of stuff in use over the next 6 months, and you'll gradually get used to how these concepts work. So don't panic if you're not following along fully at the moment. Just try and do as best you can, and please do use your peer support groups if you are struggling as well. Okay, so let's kick off, and we're going to start today by talking about functions. Now, we've mentioned functions a few times over the last few weeks, and we've even shown you a little bit of the kind of structure of a function in Python. Today we're going to look at how these things work in a bit more detail, and you can have a bit of a chance to practice writing your own functions, because they are fundamentally important for virtually all of the code that you will be writing. And that's because usually when we're writing our code, we often want to write things that the computer needs to do kind of more than once. We need it to do that here, but we'll need it again later. Or we may even write something that we want to use in a completely different program that we're writing. And this all talks to the whole concept of reusability. We don't have to write everything from scratch every time. So to do that, we can use these things known as functions, and it's basically just a way of wrapping up a set of instructions, a set of programming code lines into something called a function that we can then call any point. And basically a function may or may not take some inputs. It doesn't have to. Very often they do, but they don't all take inputs. It will do something, and if it takes some inputs, it should do something with those inputs. Otherwise, that was completely pointless. And it may return an output optionally. They don't all return outputs. But by output we mean something that is passed back to the main code by the function. So this can often cause confusion. So we talked last week about the print functions, the first one we looked at. When we write print, we're calling a function called print. Print doesn't have an output, even though it is outputting something on the screen. It's not passing anything back to the main code. And you'll see an example of how that differs from the kind of thing we're talking about in a moment. But all we're really doing in the body of these functions is just providing a set of instructions, standard Python code, much as in anywhere else in our code. It's just we're sort of bundling them up and saying, this set of instructions, I'm calling this. And whenever I say this, I want you to do this set of things. So we define a function in Python by giving the function a name. We provide it with a list of inputs it should expect, if we have any. The things we want it to do, which is the body of the function, and any outputs that it should return. But it's important to remember, when you write a function in Python, when the Python interpreter gets to that point in the code, it will read in that function definition, but it won't do anything with it at this stage. It will just say, okay, I now know that whenever you give this name of this function, whenever you tell me you want this function called, I know what to do, but I'm not going to do anything until you tell me to do something with it. So that's important to remember. So most of the time so far, you've seen that you write an instruction, and the interpreter will go through line by line and carry out those instructions. A function definition, the thing it's carrying out is remembering what to do if that function is called. So it's called a definition because we're defining what the function is, but we're not using it at this stage. So, as I say, a function basically is a set of 0 to many inputs passed into something that we want the function to do with these inputs if we pass them in, and flowing out maybe 0 to many outputs. So there's lots and lots of inbuilt functions in core Python. I just mentioned print as an example. Input you used last week, that's an example of a function. There's lots and lots of these that you've already seen and that you will continue to see. But we can also write our own functions as well. And most programs that you write can and should have functions within your code. Now, to define a function within Python, we use the def command, def, and we specify the name of the function that we want to give it, the inputs to the function, if there are any, the block of code that will represent the function's inner working, and we often need to return an output, but as I say, not always. It's important to stress at this point, when you're thinking about how you design your functions, it's good practice to have a function that does one thing well. Okay, that's an important habit to get into. It's bad practice generally to have a function that does lots and lots of different things all at once. Now, that's not to say you won't have multiple instructions in order to carry out this one thing that you need to do, but it should have a very clear definition of this is a function that will do this, and it should do that one thing well. And that's how you should think about those functions. And if you need something else done in your code, then you should probably think about having a separate function that may then be called after. That improves reusability as well, because it means that you may, in another piece of code, for example, or a different place in that same code, you might need to do that bit again, but not this bit. So you're making it more atomic, and that improves the reusability. So let's look at an example. Let's imagine that we want to write a function that takes two numbers, multiplies them together, and then works out basically whether the result's more than 100 or not. It's a pretty abstract function, but let's say that's what I want it to do. So here we've got the function definition in Python. You can see I've used the def keyword, and then I give the name of my function. I can call it pretty much whatever I like. It needs to start with a lowercase letter. Capital letters at the start are reserved for classes, which you'll come on to next week. But here I give my function the name multiply and check. Again, good practice to try and name your functions so that it captures as succinctly as possible what your function is doing, so that you can easily remember which function you need to use at a glance, and B, to make it easier for other people to understand it as well. So multiply and check is going to be the name of my function here. You'll probably want some verbs in the name of a function. Remember, a function is a doing thing, it does stuff, so they're probably led by verbs. So I've got my name of my function, then I open some standard brackets, and I put in any inputs that I would be expecting. Now, if I'm not expecting any inputs, I still have to open a bracket, but then I would just immediately close it again. but I still have to have the brackets to indicate that it's a function definition. So here I've got this function will require two inputs, and I've named them here number1 and number2. The names don't matter, and they don't, as you'll see later, they don't have to match the things that are being passed in. It's just whatever we call these things here, that's how we'll refer to them in the main body of the function. So the first input we'll refer to as number1, the second input we'll refer to as number2. And again, you want to name these things so that it makes sense what they contain or what they represent. So then we have a colon after the brackets, and then we have an indentation. VS Code and other IDs will automatically indent this, or should do. And everything in that indentation is then representative of the function. So all of this stuff is only then run when you call this function, and not at any other point. So this represents what we call the function body. So you can see in the body of this function, what we do is we multiply number1 by number2, and we store that in a variable called result. And then we check using a simple piece of conditional logic, if the result's greater than 100, return true, and else return false. So these are the outputs. This is how we pass back outputs to the main code. If we've got any outputs in our function, we use the return statement, and return basically means hand this back. Okay, so return, and here I'm returning some Boolean values. So I'm either returning the Boolean true or the Boolean false. And remember, the capital T and the capital F indicate these are Boolean values and not a variable called true or false. Also worth pointing out at this stage, you may hear me and others refer to inputs to a function as arguments. It's the same thing. Okay, so if you hear the word argument, it means an input to a function. And I say that quite a lot, so I'll flag that up now. So we've written a function now, we've written our function definition, but as I say, at the moment, Python is just being told this is what this function looks like, but it won't actually do it. It won't actually carry out that code until we tell it. And telling Python that we want that function to run, that we want it to do the things that we've specified in that function, is known as calling the function. Okay, so when you call a function, it means it tells Python, right, go back to that function definition, and I want you to carry out the things that I told you to do when I call this function. Now you can call the function anywhere in the code after the function has been defined. It may seem a rather obvious point, but if you're new to coding, it perhaps isn't. You have to define the function first before you can call it. Remember, even with functions and even with object-oriented programming, the interpreter is still going through line by line and reading these things in. So if you try calling the function before you defined it, it'll say, I don't know what that function is. It hasn't got that far yet. So do bear that in mind. However, once we've defined the function, we can call that function, and we can call it as many times as we like. We can call it once, we can call it 100 times if we like. Now, when we call a function, we have to give the name of the function to say which function that we are calling, but we also have to provide any inputs when we wrote the function definition that we said that we needed. So if you recall on this one, this says it's expecting two inputs. Okay, now it doesn't matter that we've named them number1 and number2 here. That's just so that we can refer to them as that in the function definition. That's largely regardless, but it's expecting two inputs. Okay, and because of the nature of this function, they're going to need to be numerical inputs because we're going to perform a mathematical operation on them. So we have to pass those in when we call the function. And similarly, if our function is passing it out any outputs, if we've got any return statements, which we have here, then we need to capture that output. The function is going to pass it back to us, and we need to store it somewhere. We need to do something with it. And if you don't, it's going to throw up an error. So in this case, we need two inputs for our function. and it's going to pass back a value, which it'll be a Boolean value, it'll either be true or false, depending on what gets passed in. So here's an example of that function being called. Here, what I'm doing, I'm getting the user to input two different numbers. You saw an example of this kind of thing last week. Get them to input a number and then cast it as an integer. And then I'm going to call this function. So I use the name of the function, then I open my brackets, and it needs two inputs. And the two inputs I'm going to pass are the two numbers that the user input here. So that's user input 1, user input 2. So that's the tick for giving it the inputs that it needs. But because that function will pass back an output, we need to store it somewhere. So we use the assignment operator to do that. So I'm going to store, remember it's going to be a Boolean, it's going to either be true or false that gets passed back from that particular function. So I'm going to store that in a variable that I've called isResult over 100. Okay. And here, if I put isResult over 100 equals, remember equals is the assignment operator, that basically says, let the output of this function be stored in this variable. Okay, so just as you've seen before with variables last week, where we gave a variable name, then equals, and then a value, we're doing the same thing here. It's just that rather than hard coding the value and specifying what it is in the code, here we're saying call this function, and in doing so, it'll pass you back a value. That value should be stored in this variable. So it'll either be true or false. And then I've got a piece of logic here that I can say, well, if the value that was passed back and stored here, if that's true, then I can print this message. Now, as I said, some functions don't need inputs or outputs. So here's an example of a function that I've written that doesn't take any inputs and it doesn't pass back any outputs either. So here I've got a function called say hello. You'll see there are no inputs, but I still have to use my brackets, so I just simply open and close them. And all this function is going to do is print these 3 lines of text. So there's no output. There's an output to the screen, but there's no output passed back to the code. So when I call that function, I can just give the name. I don't need to put anything in the brackets because it's not expecting anything. In fact, if I do, it'll throw an error because it's not expecting anything. And similarly, I don't need to assign anything to a variable because nothing's getting passed back. So I can just use the name of the function and open and close brackets. So this is similar to the print function you've already used, where you just say print, open brackets, and you can, of course, with the print functions I mentioned last week, you can open and close brackets because there are optional inputs on a print function, and if you don't pass in any, it'll just create a new line. Now, sometimes you might want, most of the time in functions, if you're following the do one thing well, most of the time the thing you pass back is a single thing. But there may also be circumstances where you write a function and you need it to return multiple values. Okay. Now, there are basically 2 ways you can handle that. You can either return those values separately as separate outputs from the function, or you can, before you return them, you can put them into a single structure. So, for example, a list. So you could stuff them into a list and then pass back the list. So you're just passing back one thing, but it's a list that contains multiple values. Now, for the first approach, if you want to pass back the values separately, and you'll see examples of this throughout the course being used, what we do is we list out the values that are being returned using commas in the return statement, and when we expect them back the other side, we use commas for the variables that we want them assigned into. So let's have a look at an example to make that a bit more real. So here I've imported the random library simply because I'm going to use that in my function. But I've created a function here called generate 3 unique random integers. It's going to take 2 inputs that I'll refer to as low and high. Basically, all this function does, it first of all creates a variable called number1, randomly generates an integer between the low and high that were passed in. Then it has an infinite loop in a while loop, and it basically tries to pick another number between these ranges, and it will keep trying them until it finds one that doesn't match the first number, and then it does this again for the third number. So we'll end up with 3 unique random numbers. Now, what we do here, because we've got 3 things to pass back, I could pass them back as a list. I could put them in a list and then pass it back. You'll see that often in what you do. But there might be some reason I want those things to come back separately because I don't want them all together. So in this case, I'm going to return those 3 numbers separately. And so I use my return keyword in the same way I did before, and I simply list the outputs and I comma separate them. So we literally just list, I want to return number 1 and also number 2 and number 3. Okay. Now that means that when we call the function, there will be 3 outputs passed back. So in this assignment here, it's no good just having one variable on the left-hand side of this statement, because there are 3 things that are going to be passed back. So we need to give 3 variables that will store these 3 things here. And so here I'm going to store them in some variables called num1, num2, and num3. And it's important to note it will store them in exactly the order in which it was returned. So this number that we refer to as number 1, the first one that gets generated, that will be the first thing that gets passed back, and that will be stored in this variable, whatever we call it. Similarly with number 2, that's the second one, that's this one up here. That will be stored in the second variable, whatever we call it, etc. So it will come back in that order. So bear that in mind. So here I call that function with the inputs 1 and 10. So it'll basically generate 3 random numbers, unique random numbers between 1 and 10. And you can see some outputs of how that would run. But as I said, you might want to return multiple values as a list instead. So here I've got exactly the same code in the main bulk of the function. The only difference is down here, where instead of returning 3 values separately, I've created a little list. I've just called it returned list. I've stuffed my numbers into there, and I simply then just returned list. And because I'm only returning one thing, even though a list contains multiple values itself, then I only have to have one variable catching it on the other side. Now, it's important to say at this stage, because this can trip people up a little bit as well. When you write functions in Python, it's really important you understand the difference between what is termed a local variable and a global variable. So a local variable is one which lives inside a function, but it is not visible outside of that function. So anything that any variables that we create within a function cannot be seen outside of that function. So you can see here, in this example, I created these 3 variables in the function called number1, number2, and number3. If I try to refer to those outside of the function, it'll say, I don't know what you're talking about. I don't know what number1 is. They only exist within this function. Now that means that you can also create outside of that function another variable called number1, and that will be a separate variable to the one that lives within the function. Okay, because these are local variables. They are local only to that function. They only exist whilst that function is running, essentially. The inputs as well that are passed into it are also examples of local variables. I should have pointed that out. Now, those are local variables. A global variable is one which is defined outside of a function. Okay, and they can be used and referenced anywhere. Python can see them completely. However, just to add a little wrinkle, if you want to change them within a function, then you have to use something known as the global keyword. Now, it is generally not recommended to do this. It is considered actually bad programming practice, so I'm not going to teach you how to do it. But just be aware, if you see a keyword called global before a variable name, it basically means this. It's a way of giving a function kind of permission to change something globally. That's bad practice. You are supposed to do things like pass over to the function things that it needs to work with, and then it would pass those things back. You're not supposed to directly reference things from within a function unless you are working with objects or external objects, but variables within your code you shouldn't be changing in that way. So just bear that in mind, that the thing that will trip you up the most until you get used to it is this idea of local variables, that whatever you call these things in here, they only exist within the function. They don't exist outside of the function. Okay, wow, I only went 2 minutes over. That's really good for me. So, Sammy, any questions that have come up on any of that?
So we have one question about what happens if you only do num1 equals generate 3 random unique integers? Will the program just error out?
Oh, I see. So you'd only have what you're saying if you only had num1 and you didn't have these two here.
Yeah.
Yeah, yes, it will, because it's trying to pass back. I think it does anyway. I think it errors. Try it. But
Yeah,
I think it errors. It needs to go somewhere.
yeah, that would be, I think, yeah, that would be a good one for people to try and report back. The other one, and I think the same thing might be nice for people to try out, is when the interpreter encounters a return statement, does it exit the function, similar to the behavior of break in loops?
Yes, it does. So the second it encounters a return, it stops. It says, right, pass it back, I'm done, and the function is finished. Okay. Now, you raise an interesting question, because there are something in Python known as generator functions, which you are going to learn about in the next module, because SymPy, the package that we use for discrete event simulation, is built around these things called generator functions, and they work a little bit differently. But for now, don't worry about that. We'll come on to generator functions in the next module. Standard functions, you hit a return statement, it says, right, pass this back, I'm finished, and the function closes.
I think those are the only two that have not already been answered.
Great,
So,
cool. In which case, oh no, we skipped on there. So you're now going to go into your groups, and you're going to take on the tasks in Notebook 1F underscore 1 in your repositories. So you'll have 40 minutes to do that, and take a 10-minute break. So we'll resume at 10:50. Let me just bring up the notebook here. So this is the one you're going to be doing. Work as a group to help each other. There are 2 tasks within this notebook. Read the instructions carefully. As ever, it will ask you to do a series of things. Good tip with this kind of stuff is always just break it down bit by bit and gradually build up the code. And usually the second task is kind of a shorter instruction, but gets you to think a little bit more about how you might do that. So have a go in your groups at that exercise. If you do manage to get through those things early, then have a go as a group at writing some other functions of your choosing. Okay, I will stop sharing there, and I'll open up the breakout rooms. Sammy and I will be floating around. Hello everyone, welcome back. So my apologies. You can probably guess by the rustling sound that my cat is just eating some treats. Apologies for the next 2 minutes. I just wanted, before we went on, I managed to get around a few of the groups. You all seem to be getting most of the concepts of this. And actually, even if you were struggling on little bits, I think you managed to get the gist of it. But I'm just going to put Sammy on the spot for a moment. Sammy, was there anything you sort of noticed sort of going around the groups, anything that you think might be worth kind of flagging up to everyone in terms of this? Sorry, I'm putting you on the spot because my cat is eating.
So I think, yeah, people seem to actually be getting on really well. I think everyone sort of came up with the idea of using the modulus operator for the second task. One thing I noted was just there for the I'm just trying to think how to describe it best without sharing code. Just on the doing conditions within the list comprehension. So this is quite tricky, actually. And I think, list comprehensions came up as something that a lot of people found difficult last week. So don't worry if you went with a different solution or if you found it a little bit difficult to follow list comprehensions. We will go over them in the revision session a week Wednesday. We'll spend quite a bit of time with them just to make sure that everyone's happy with them.
Yeah, absolutely. Yeah, I'd echo that. I think, sorry, I'm just putting the camera back on. He's finished now. Yeah, list comprehensions are a bit, as I said to one of the groups, they seem a bit weird to get your head around initially. They are not essential by any means, but they are very nice, and they're very elegant, and they are slightly more computationally efficient than. So basically, for loops are atrociously inefficient in Python. For most of the things you'll be doing, you'll end up using NumPy rather than lists, which we'll come on to later. But nonetheless, they are a nice little thing to get your head around. So, but don't feel bad if you don't understand them fully yet. They are a bit weird, but the once you do, you'll find them really nice to use. So I think it's worth sort of persevering with them, and you'll see lots of examples of them being used within the course. And it's probably more important at this stage that you understand how to read them rather than write them, because you'll be seeing examples of them in the code. So that's the kind of priority there. But yeah, no, really good to hear that. I think much as I think I managed to get through about half of the groups and saw much the same in terms of how people are getting on with this. So really good to see. Remember, you only started your Python coding journeys last week, for most of you did. So really good to see how far you've come already. Okay, we'll plough on. So we'll start on our next topic. Let me share my screen and then open up the slides and get back to where we were, which is here. So let's now talk about exception handling. So particularly when you start out in your coding journeys, you'll encounter a lot of errors. I say particularly when you start out, you'll encounter errors throughout your coding careers all the time. This will be routine. Your code won't work as expected. Now, sometimes it's because we've done something incorrectly, but sometimes the code goes wrong because of something that we didn't anticipate. Because of there's nothing wrong with our code, but something's gone wrong elsewhere. Like we've asked the user for an input, and they've done something that we didn't anticipate, and it's gone wrong. So, for example, we might ask the user to input a number, as you've done multiple times now, and they type in something that isn't a number, and the program will then terminate with an error. And you've probably seen things like this already in sort of trying out the sort of toy code examples. Now, where we've got something like that, or for reading something in from a file, which is more realistically the kind of thing you'll be doing, we don't really want our code to crash if something unexpected happens. That's not really good practice. A better approach is to use something known as exception handling. Now, exceptions are just basically a fancy way of saying errors. So exceptions are errors in programming. And basically exception handling allows us, much as the name would suggest, to handle those errors. It allows us to catch them and basically say, if that happens, you can tell Python what to do if it finds an error. So rather than crash, you're telling Python, if something goes wrong here, I want you to do this. And that's known as exception handling. And in Python, we do that using try and except statements. And basically, it's just a way of saying to Python, I want you to try doing the code in the block of code under try. And if anything goes wrong at any point, then I want you to jump out of that and run the code in the except block instead. So in this example here, we import the random library, and then we've got a try except statement. And again, we've got indentation. So this block of code, which is just one line, is the try block. So this is the code that should be tried by Python. And if anything goes wrong, I mean, there's only one line of code, but if anything goes wrong with that one line of code here, then it will run this stuff in the except statement. If nothing goes wrong, this will never get run, this stuff in the except statement. But it basically says, try this, and if anything goes wrong at any point, then run the stuff here. So here we've got to try a user input where we're going to get an input from the user, and then we're going to cast it as an integer. And then if something goes wrong, i.e. if the user types in something that is not able to be cast as an integer, then instead it will then run this piece of code here, where it'll say, sorry, that's not a valid number, and it'll automatically choose one for them, because the rest of our code is presumably dependent on a number being entered. So that's presumably why we've put it in. So here I've chosen to handle that. I could have handled it by saying, no, you need to input a valid number and making them input something else. Here I've decided to do that by saying, okay, well, I'll pick one for you. How you decide to handle it is entirely up to you and the design of your program and what you're trying to do. But the point is we're using exception handling here so that the code just doesn't crash if they do something wrong. Now, normally, try and accept is all you'll need for exception handling for most cases, but you can actually extend a try except statement by using else and finally as well. And it works like this. We can, in the try block, we're saying try this code, and if anything goes wrong at any point, then it will run this block of code in except. Now, we can also use else, which says run this code only if you didn't get any exceptions. So if you managed to get all the way to the end of try and there were no problems, then run this block of code that was in else. And we can also have a finally block, which it says run this block of code regardless of whether you got errors or not. So regardless of what happens up here, then run this code. So try this. If anything goes wrong, run this. Otherwise, don't run this. If nothing went wrong, then run this. And run this either way. So I flagged that up because you might need it. You may indeed need it for the next exercise. So probably worth noting. But generally speaking, try and accept will get you most of the way for the stuff you'll be doing, I think. So just a little brief note there about exception handling, because it is quite important whenever, and it's particularly important wherever you're trying to get some form of input, external input from the user, whether that be them manually typing something in, or you are trying to read in a file, or you're grabbing a download from a web reference, and that it may not exist, or the server might be down, or something where something could go wrong outside of your control. Then it's worth handling that. So that I keep talking about files. So let's talk a little bit about file handling now. So so far, up to this point in the Python training, we've only looked at storing our data temporarily in variables. And remember, in the principles of programming, we talked about how a variable is basically just a box that is stored in memory, and it's got a label on it which says it gives it a name which indicates the type of information it's storing, and there's a value inside. But that only exists for as long as that particular session exists. So when you close down VS Code or shut down your computer or whatever, when you come back, those variables are gone. And that's the point of variables. They are just designed for the computer to remember something for the moment whilst it's running this piece of code. But we may also have inputs from the user or outputs that we will generate from our code that we need to store longer term, i.e. between sessions. So it might be things like if we're building models, we might need to have parameters for our model, and you could get the user to type in and input them each time, but that's not a great way to do it. So you might instead choose to read in parameters from a file. Now, actually, the best option is when you come to module 7, and Sammy will talk to you about web app development using Streamlit, where you can develop a web app, and that's how you'll plug in your parameters. But before that, you may want to read in files, and you may even in a web app have a file. You might have hundreds or thousands of parameters for a particularly complex machine learning algorithm or something like that, and you want to the user to basically just change little bits of it. You don't want to have to imagine you had 100 parameters. You don't want the user to type in everything from scratch each time. Similarly, when you have outputs from your models, for example, your results, then you may want to store those so you've got reference to them later. You may need to report on them, for example. So there are lots of different ways in which we can work with files in Python, lots of different ways, and you'll see various different approaches throughout this course. Most of the time, though, for the kind of things you will be doing, modeling and data science, you will be likely interacting in some way with comma-separated value files, CSV files. I suspect many of you are aware of what CSV files are, but for those who aren't, CSV files are basically just text files that have discrete values that are separated by commas. And that makes it easy for them to be read into and exported from tables and spreadsheets. So you can, there's in Excel, if you're using Excel, you can export a spreadsheet as a CSV file. Similarly, you can read them in, although be careful about reading in CSV files in Excel, because it can do little formatting things that if you're not careful, you can accidentally corrupt your CSV file a little bit. So basically, we can think of a CSV file as being data that is separated into rows or records, i.e. each line, and columns where each column is separated by a comma. So here we've got an example here where we've got sort of names as the first entry before a comma, and then some sort of yes or no flag after is the second entry, and then perhaps that's an age as the third entry, and a county as the fourth entry. So, and then we've got each row basically represents maybe a different patient record. Now, there's a library within Python called CSV, which allows us to work with comma-separated value files really easily. It allows us to read and write them with ease. And actually, there's an even easier way to work with CSV files that is more appropriate for what you will be doing most of the time. And that's using a particular pandas function, but we'll come back to that later. You may not always be doing that, and so this is the non-pandas approach, basically, of doing this. So let's say we wanted to read in a CSV file. This is our CSV file here. It's a very simple CSV file. It's basically just got sort of two columns. The first entry on each row is just a name, and the second entry is an age. Okay, really simple CSV file. Then what we can do is we can read that in, and we could store the names in one list and the ages in a second list. And we can do that really easily using the CSV library. So first of all, I import the CSV library. It's called CSV. Then I'm just going to set up here two empty lists. I've called it one list of names and the other list of ages. So it's very clear what each one's going to store. And then we use this line of code here. Now, this is known as a with statement. So you'll see these quite often in Python, and throughout this course you'll see with statements used a lot. Particularly, you'll see them used in a different way with SymPy, and we'll come back to that in Module 2. But basically a with statement says, do all of this stuff in the block of code with this in hand. Okay, so what this is saying is, I want you to open the file called filename.csv. So that's the file name. And I want to open that in read-only mode. So that's the R. We'll come back to that. And I want you to cast that as an alias of F. Remember, we talked about aliases was it last week or the week before, maybe both, where we said that when we import libraries, we can import them with an alias. And we basically just say, we use the word as, and then we give it a name. And basically what that means is, from this point forward, I'll just refer to it as this. And that's what this is saying. It's saying, open up this file with this file name and open it in read-only mode. And henceforth, I'm going to refer to that file that's been opened in read-only mode as F. Okay, so that's all the as F means. It's just an alias. But I'm going to do this with a with statement. So basically, do all of this with that file opened. Okay. Now, the advantage of doing it this way is that there are different ways to do it. You can do it without the with statement and just open the file. If you do it that way, you have to remember to close the file again after, because it will remain opened unless you close it. And if you don't close it, very weird things can happen. So it's far safer, and it's actually a more elegant approach to use a with statement. So basically, Python will do it automatically. It'll run this code with all of this. This is all the stuff you want done while that file is open in read-only mode, and as soon as it's finished, it will just automatically close it. So that's the better approach to use it. So with that file, that CSV file, open in read-only mode, what I'm going to do here is I'm going to create a reader object. We'll learn more about objects in Python next week, but remember we talked a bit about object-oriented programming. So this creates an instance of the reader class, basically. So it creates a csv.reader, and we need to pass it, to create a reader object, we need to pass it two things: the file that we want it to read, which remember we're referring to as F because we've set up this alias, and the delimiter, which in most cases is going to be comma for CSV, but you can have other delimited files. You can have semicolon delimited and other things. Depends on your file, but 99% of the time you'll be using delimiter equals comma. So create a reader object that's going to read this file, and it's delimited by commas. And then all I'm going to do here is I'm just going to use a simple for loop. And I'm going to say for each row in the reader, because it'll go down row by row, line by line in our file, then I want to basically store the first value, i.e. the one that comes before the first comma, in our list of names, and the second value, i.e. the one that comes after the first comma and before the second comma, if there is one, in our list of ages. Okay, and we can refer to these by however we refer to this. So I usually just use the word row. Basically means the line. We can refer to them like a list element. So we can, if we say row 0, that means index 0. It means the first item before a comma. Row 1 means the second item. Row 2 would be the third item, etc. So if we run that piece of code, we'll end up with two lists. One will have a list of names and the other will have a list of ages. So as well as reading CSV files with the CSV library, we can also write them, and it's equally easy to do that. So again, here I've imported the CSV library. I've set up a little list here which will represent my column titles, because I may want titles in my CSV. They don't always have them, but some do. This one's going to. And then I've set up a few lists that I want to set up. So basically, I want to write a CSV file that looks like this, that's got name and ID on the first rows, the kind of headers, and then it'll have the name and ID for each entry. So we've got Dan, Sammy, and Amy, and their respective IDs. So here I'm going to combine those things into a list of lists. So remember we talked about last week that a list can hold any object, including another list. So here we have a list that contains itself 3 lists. And then what I've done this just to make it easier to write the CSV file. So again, I'm going to use the with statement here. I'm going to open the file. This time I'm going to open it in write mode because I need to write the CSV file. So I use a W. Again, we'll come back to that. And I'm going to specify this new line parameter, and I'm going to open and close my inverted commas here. So I put in nothing, but I put in an empty character. Now, that you have to do if you're using Windows. We discovered this a couple of years ago. If you don't, you'll end up with a CSV with a blank line in between each entry, and it's an absolute nightmare. So if you don't have to do this if you're not using Windows, although it doesn't matter. You may as well do it because it'll still work. But if you're using Windows, this is absolutely essential, unless you genuinely do want a blank line in your between each entry in a CSV file, which I can't imagine you do. You have to enter this new line equals and then open and close inverted commas. So otherwise, this is the same as before. I'm going to use the alias of f for the opened file. And this time I'm going to create a writer object instead of a reader object. So I'll create a CSV writer. And again, I say this is the file, the opened file that I want to write. And this is the delimiter. It's going to be comma delimited. Again, most of the time that's what you'll use. And then what I'm going to do is I'm going to write the CSV file line by line. Now, because mine has I want it to have column headers, I'm going to add this extra line of code here where I'm going to use the writer to write a row, and I'm going to write that list here, and it'll write it as 2 entries in a CSV file. So you can pass it any iterable object, like a list, and it will write out those entries as a line on a CSV file. Now, if you didn't have column headers, then you could just ignore that bit. But I do, so I'm going to add that in. And then for the rest of it, I'm just going to loop through my list of lists. That's why I put all these lists in a list, so that I could just go through each list in my list of lists, and I'm going to tell it to write the row based on that list. Okay, so whenever you want to write a row of a CSV file using the CSV writer, you just pass it an iterable object like a list, and it will write that out. Each element of the list will then come out on that line. Now, I keep talking about these file access modes. We've talked about R and W. There are actually a huge number of different file access modes across Python. Far more than you will ever want to use. So I'm not going to go into showing you all of the different modes. I'm simply going to show you the 4 most common ones that you are likely to use. To be honest, 3 of those are more common than the other. So R basically means open the file read-only and start at the beginning of the file. W, which we just saw, means open the file write-only and start at the beginning of the file. Now, there may be situations where you want to both read and write in the same file operation, in which case you could use W+, which means open it in read and write and start at the beginning of the file. Generally, though, you probably are doing things either this operation will write some stuff or this operation will read some stuff. So you probably won't use this one as much. This one you may, though. In fact, particularly for modelling, you may use this quite a lot. And this is A, which stands for append mode. Now, append mode basically means open the file in a write mode that starts at the end of the file. Okay, so rather than starting at the beginning of the file, append mode will find the current end of the file and it will start there. And you're probably already working out why this might be useful. So if you were to use write mode, let's say you were writing a file, you built a model, and you wanted to write out after each run of the model, you wanted to write out to a results file that was collecting all the results. Okay, and that's something you may well do. If you were to open it each time in W mode, in write mode, every time you open the file, it will start from the beginning and it'll overwrite the last results. Now, sometimes that's what you want. Sometimes you may want this file to be written as the results from this particular run. But if you're collating lots of stuff and you're adding to it as you go, then you probably want it in append mode. And append mode will do the same thing, but it will start at the end. So it'll add it on to the end of what you've already got. Whereas W will start from the beginning. Basically, it'll overwrite what you already have. Now, it's important to state that the W, W+, and A modes will create a new file with whatever file name you've given if that file does not exist. Okay, so if that file doesn't already exist, it will create a brand new file. But it won't do that if you use a read mode, because obviously that doesn't make sense. If you're opening it in read mode, it needs to read something. If that file doesn't exist, it can't do that. And it will then throw up an error, which hopefully you've caught via an exception handle. And as I say, if you do want to add to a file, you need to make sure you open it in append mode. If you use write mode, it's going to start at the beginning and it will wipe out your file. So also be very careful from this point forward about throwing around file names in your directory structure, opening in write mode. You could end up overwriting files that you don't mean to. So be careful with that. And part of the reason why we advise during the training to have all your HSMA materials in a kind of its own folder. So just be, because you can always re-download stuff from HSMA. So just be aware of that. Don't go giving file names of important files that you need to use for other stuff and opening them in W mode and then accidentally overwriting them. Because you can do that. Depending on the file permissions, you may have administration logs on it, of course. Okay, so we've talked about exception handling now, and we've talked a bit about reading and writing CSV files. Again, using the non-pandas approach, you'll end up in reality using the pandas approach far more. Believe me, when you see pandas this afternoon and you see how easy it is to read and write CSV files using pandas, you will wonder why I bothered teaching you this bit. It is incredibly easy. But nonetheless, you're not always going to be using pandas. There will be some stuff, including some stuff in the course, where you need to read and write a CSV file without using pandas. And so it's important to show you that. So in your groups now, you're going to work through the next notebook, which is 1F_2. I'm going to give you half an hour to do that. I think because we're a tiny bit over, so I'm just going to give you the half an hour, but if you do want to obviously stretch your legs within that, please do. And then when we come back, we'll run through until lunch. But that will give us that'll buy us another 5 minutes. So any questions that have come up in the chat, Sammy, that need covering?
Sorry, I'm just posting some stuff in the other channel. I've just got my list of questions back up. So one of the questions is why or when would we use this technique as opposed to pandas? That was the first one.
I mean, it sounds a bit, it sounds a sarcastic answer, but it's not. It's when you're not using pandas, and you may not always want to use pandas. Is beautiful, but it may be overkill for what you need. And so it may be that you are. I'm trying to think. There are examples in the training that I can't remember right now, where you'll do this without using pandas. But yeah, you won't all, just because you've got a tool available that you use a lot doesn't necessarily mean you use it for everything. So there are situations where you won't use pandas, but you still need to write out a CSV file, for example.
Fabulous. And I think the only other one was what is the difference between open foo as F and F equals open foo or file? And so I think just I think you did have a slide or I think you briefly explained that verbally that by using open foo as F and indenting all the code after that, you don't have to faff around manually closing it.
Yes, that's correct. And, yeah, so this basically says just do all of this with the file open, and then it'll automatically close it. You can do it the other way, which is a slightly more old-fashioned way of doing it, but you have to then remember to manually close the file. Which, you know, if you're used to that approach, if you've done this before, that's fine. But just be aware, weird things will happen if you don't, because if you leave it open and then go and do some open the file somewhere else, very odd things will start to happen. We've had HSMAs who've accidentally done that before and had very weird outputs in their files. So yeah, be careful about doing that. But this is the safer method. Because you'd have to remember to close it, basically. And also with statements are nice and elegant, and they will get used to using them for SymPy where they are required.
Fantastic.
Sorry,
sorry, one more. We just had a question. How much exception handling should be used in programs? Should it be used, for example, in every loop, or is it a bit more of a case-by-case basis, I think?
So basically you should do it whenever you're getting some external input that you have no control over or you have no direct control over. You know, you shouldn't use it as a replacement for you writing your code correctly. That's not what exception handling is. What it's there for is to say, okay, well, assuming everything goes to plan, this code will work. But what if something goes wrong when I give this over to someone else, or I give this to a user, or I input something, or I provide a file, or I'm giving a file reference. Any situation where you've got some sort of external input in some way, you should absolutely have exception handling in there just to make sure. Or indeed, you might have cases where you've got some complex operations that the computer's going to be doing, and you want to try and catch if anything goes wrong as a result of that. So anything where it is unclear whether you can't easily answer the question, is something going to go wrong just by looking at your code? That's probably a good rule of thumb.
Fantastic. That's all of them then.
Great, thank you. Okay, so in which case, I'm going to get you to go for half an hour. So just after 10:02, we'll resume. I will open up the breakout rooms now. Don't forget, make sure that somebody in your group is sharing your screen, and do work together to help each other on these. I know some people are struggling a bit more, which is, don't worry, it's completely normal at this stage, so don't panic about that. But make sure that you are helping each other as much as possible. And please do share your screen, because when we come round, it makes it easier for us to see how you're getting on as well. Okay, I'll open up the rooms now. Hi everyone, welcome back. Managed to get around a couple of the rooms. Seemed like you're mostly sort of okay with this. I've posted the solution in the class Tannoy as well, if you want to look at it. But remember, all the solutions will be uploaded tomorrow on the GitHub repo as well. But if you wanted to have a look before that, there's a copy of it in the Slack channel on the class Tannoy. Just to flag up, Sammy's reminded me that something I didn't mention, that this, and for quite a few of the sessions now moving forward, in the repo, the GitHub repository you've downloaded, you'll see that there's a folder called Lecture Examples. That contains the various bits of code that you saw screenshots of earlier, and is a way for you to be able to access that code directly if you want to run those examples or copy little bits out. It's always worthwhile, particularly for these as you're learning these new things, to try typing it out from scratch, really. But just be aware that those things are there if you need to refer to them. And that'll be the case moving forward. There will be lecture examples for a lot of the sessions, a lecture examples folder, where you'll have sometimes extensive hundreds of lines of code for, particularly as we get into kind of the natural language processing stuff, where you'll be able to use those code examples directly. So just sort of thank you, Sammy, for reminding me. I completely forgot to mention that. Okay, let me share my screen. So the next bit we're going to cover before lunch, or mostly cover before lunch, and then we'll do a tiny bit after, is the concept of NumPy. So we've talked about functions and about files and about exception handling, but now we're going to cover NumPy and Pandas for the rest of the day. So NumPy and Pandas are two of the most important libraries you will use for data science, and we're going to start with NumPy, which is the more difficult one. I've done that for a couple of reasons. Pandas, I think most of you will probably be all right with, at least get the gist of it quite quickly. Because Pandas is a bit like kind of a supercharged Excel in Python. That's you'll be able to relate back to it. NumPy is a bit more weird. Now I'm flagging this up now because it is a bit more complicated, and I flagged that up deliberately because I don't want you sat there thinking I'm completely lost. I have no idea what Dan is talking about, and feeling as though you're somehow sort of falling behind. There may be others. In fact, I suspect many of you will not grasp all of NumPy at this stage. I would also recount the story. I remember my colleague Tom told me he used to teach NumPy as part of an undergrad course to people who were well used to programming and one student once came up to him and said about NumPy, "This is too much. It is too much," and they were visibly distressed by NumPy. So I'm flagging that up now. I am hoping that you won't find this too much, but you may find it a little bit more challenging than some of the things we've covered so far. So just be aware of that. But I've tried to make this as friendly an introduction to NumPy as possible. Much as with Pandas later, I'm only going to skim the surface of the things you can do with NumPy. You will see lots more examples of stuff you can do, really neat stuff you can do with NumPy throughout the course, but even that will only skim the surface, and there's so much more out there. We can't possibly teach you all of NumPy, much as we can't possibly teach you all of Python, but hopefully this will give you a bit of grounding in some of the basics, and will also show you why this slightly complicated thing is so worthwhile. Okay, so NumPy is an abbreviation, stands for Numerical Python. And it's really, really important for scientific computing, and it provides a lot of features that are fundamental for scientific computing. One of the major ones is it provides the ability to work with large multi-dimensional arrays hugely more efficiently than if you don't use them. Okay, now the reason for this is that NumPy arrays are written in a language called C, which some of you may have perhaps used or at least heard of. I mentioned a few weeks ago, Python is a lovely language. It is not very efficient. Python is very friendly, but that friendliness comes at a cost, that it is slower than some languages that are a bit closer to the metal, like C. NumPy arrays are written in pure C code, which makes them hugely more efficient, and I will show you later how much faster they are. And for the kind of examples you're going to be using in the exercises, you'll kind of think, well, what's the point? It doesn't seem much benefit. When you get onto stuff like machine learning, it becomes almost essential, because you're suddenly dealing with huge arrays. You're not dealing with a little list with 5 elements in it with 5 numbers. That would be overkill for to use NumPy for that. You'll be using things with thousands, hundreds of thousands of entries spanning hundreds of dimensions. So NumPy does become quite important, and particularly for the machine learning stuff, the natural language processing stuff, that will all use NumPy in some way. So NumPy comes with a lot of distributions, scientific distributions of Python. Anaconda is one such example. So most of you got the Anaconda distribution. It comes pre-installed with that. And so in order to work with NumPy in our code, all we have to do is import it. And this is one of the packages that has a conventional alias. So I mentioned there are a few of these where you are convention dictates that you don't just import NumPy, you import NumPy under an alias. So we say import NumPy as, and the alias we use is NP. Now, as I mentioned before, that alias can be anything you like. You could call it pasty or tea cake, if you like. You can tell it's getting close to lunch. But you'll be frowned upon most severely by members of the Python community if you do so. You should always type the words import NumPy as NP, and you should therefore, henceforth in your code, refer to NumPy as NP. Okay, do not break the golden rule of not referring to NumPy as NP. So just flagging that up. Pandas has got a similar one, which we'll talk about later. So the main object in NumPy is what's known as a multi-dimensional array. And I keep saying the words multi-dimensional array, and you may be sat there thinking, what on earth are you talking about, Dan? What the hell is a multi-dimensional array? Okay, well, let's break that down a little bit more simply, and then we'll break it down a bit more simply again. So let's consider what a one-dimensional array looks like. You've already been working with these. You've been working with lists. Okay, so a simple list is an example of a one-dimensional array. It is an array with one dimension of numbers. We can also have things called two-dimensional arrays, which are arrays within arrays. And you've already seen a little example of that as well, which is where we've got lists within lists. So there are two dimensions of array there. There's the dimension which holds the kind of three outer lists in this example, and the dimension which holds the elements within each of those lists. Okay. We can also, by extension, have three-dimensional arrays, which is an array within an array within an array, and that's a list of lists, basically. And within NumPy, arrays are referred to as axes. So you'll hear the term axes in NumPy, and it basically means the dimensions within a NumPy array. Now, that probably, again, still feels a bit abstract. So let's try and pin this back to something a bit more real world that we can get our heads around. Now, the examples I'm going to give you here are not the best use of NumPy. This is how you wouldn't generally use NumPy to store this kind of information, but as a way of trying to understand a multi-dimensional array. Hopefully they're helpful. Okay, so let's think about some practical examples. If we had a list of ages, that's an example of a one-dimensional array. Okay, it's a simple list with some ages. That's a one-dimensional array. If we had a list of ages for each person in a number of groups, that would be an example of a two-dimensional array. Our two dimensions would be individuals and groups. Okay, so we might have three groups, and each group has 5 people in it, and each of those people has a different age. That's a two-dimensional array. Then we might have a list of ages for each individual within each group, within each department. Okay, and that would be an example of a three-dimensional array, because we've got individual ages as one dimension, we've got groups as another dimension, and we've got departments as another dimension. So in order to find any individual, we'd have to know their individual place within that group, and also which department. Which group, individual place within a group, which group they belong to, and in which department. Okay, that's a three-dimensional array. And hopefully that's a bit more easy to understand what a multi-dimensional array might look like, and therefore what a 4-dimensional array, or a 10-dimensional array, or a 100-dimensional array might look like. A 4-dimensional array might be, you've got a list of organizations, each of those have departments, each of those have groups, and each of those have individuals with ages, etc. So that would be an example of a 4-dimensional array. Now, in machine learning, multi-dimensional arrays are very common, because in machine learning, as we'll come on to when we get to module 4, we're basically trying to predict or classify some sort of outcome based on a series of input values, and they're referred to as features. Again, we'll talk more about that in machine learning, but it's things like, can we predict whether the patient has this condition based on their age, the number of admissions, and all sorts. And you can have hundreds of these things, sometimes even thousands of these things, okay? And each one you have adds another dimension to your array. So you can imagine, if you only had a machine learning problem that had 3 dimensions, you could just about get your head around that, a list of lists. It would be messy, but you could get your head around it. Trying to get your head around a list of lists, that's just not going to happen. We cannot, as human beings, envisage that. But if you think back to this simple example of basically you're just adding another dimension of information. It's, okay, well, they might be in a group, which is in a department, which is in an organization, which is in a subdivision of a company, or whatever. Okay, so that's effectively what you're doing when you create a multi-dimensional array. And because we end up with these huge multi-dimensional arrays when we're dealing with things like machine learning, we have to have a solution that allows us to work with those things more easily and efficiently. And NumPy gives us that ability, and it does that via something known as a NumPy array. And a NumPy array is an array that can be hugely multidimensional and retain its efficiency, and can perform extremely rapid calculations on these huge multidimensional arrays. So that's why we use them. And you'll see more of an example after lunch about why they're so useful. So how do we create a NumPy array? Well, after we've imported NumPy as NP, we will henceforth refer to NumPy as NP. And so if we wanted to create a one-dimensional array, here's an example here. I just say np.array. Remember, we're using dot notation to say from the NumPy library, give me the concept here of an array. So it's giving you an array object. So you're creating an array object basically here. And in this case, it's a one-dimensional array. It's just a simple list. Here I might create a two-dimensional array, which is a list of lists. Here is a list of lists of lists, a three-dimensional array. Before you start panicking though, this isn't how you tend to create NumPy arrays, by manually typing in all the numbers. So if you're suddenly thinking, is this what I've got to do if I've got 200 dimensions in my machine learning array? No, that's not what you do. Don't panic. This is just to get you, give you a sense about how these things, the kind of syntax for working with them, and the kind of examples that you'll use in the training as you're learning NumPy, just very simple arrays to get your head around the concept of a NumPy array, because all of that will then scale up to these huge arrays in exactly the same way. You'll perform the same operations, you'll use the same syntax, it's just they're operating now in 100 dimensions instead of 2. So yeah, in reality, you would use various things that would automatically read stuff into those arrays, and there's really neat shortcuts that allow you to do that. So before we go any further, I need to talk about the homogeneity of NumPy arrays. NumPy arrays are homogeneous, and basically what that means is you can only store the same type of data, so whether that's integers or floats or whatever it may be, across the array. And NumPy arrays are only for numerical data as well, hence the num bit in NumPy. But it has to be consistent, so you either have to have an array of floating point numbers or an array of integers. You can't have a mix of the two. And also, the dimensions of a NumPy array have to be the same length consistently across the array, but can differ across dimensions. Now, that probably doesn't make sense to you, but let me put that into a real-world example. As an example, we could have an array which represents 3 departments. Each of those departments has 4 groups in each, and each group has 10 people. So they're all different values. But what we can't have is more or fewer than 10 people in each group, or more or fewer than 4 groups in each department. You can't have a department that has 3 groups and a department that has 5 groups. That's why I said the example I gave of think about a multidimensional array as being individuals in a group, in a department, in an organization is handy for trying to get our heads around a multidimensional array. But that's not how you tend to store that particular kind of information, because you'll likely have, departments that don't exactly have 10 people in each group and have exactly the same number of groups, etc. So I'm giving this to you as a way to make this make your head hurt a little bit less, rather than this is how I would represent this kind of data using NumPy. So that's what we mean by the dimensions have to be the same length consistently. Now, that does mean that even if you are using NumPy for something where it is a bit more appropriate to use it, we will sometimes have 0 or missing data for some values, because everything has to be the same length. And we deal with that differently depending on what we want to represent. So sometimes we just put in 0 values. Sometimes we take average values. There's various different ways of imputing missing data, and it entirely depends on what you're doing. But for now, just be aware that NumPy requires there to be consistent lengths across in each dimension. So just to hammer home this point, this piece of code here, where we've created a NumPy array, this piece of code is not, the code is valid. It is not valid for creating a 2-dimensional NumPy array, however. So it will work, but that will not create a 2-dimensional NumPy array, as you might think, because here we've got, imagine this is our, we've got individuals in each of 2 groups. Here we've got one group that has more individuals than the other. That's not allowed in NumPy. Okay, so you can input that and it will not throw up an error. What it will do instead is it will create a 1-dimensional array that has 2 elements, and those 2 elements will be references to 2 different lists. That's not what you want to do most of the time for NumPy, but you won't get the benefit of NumPy doing that. So just be aware of that little wrinkle. Okay, so to refer to a particular value in a NumPy array, we work in the same way as we would for a list. We specify the index of that value, and we always start with the outermost dimension. It's all getting very, very Star Trek here, but we start with the outermost. So think about if we've got nested, it's a bit like nested loops or nested brackets. We start with the outermost thing and then carve our way in. So obviously, if we've just got a one-dimensional array, that's just like a standard Python list. So that's easy. If we want the first element, we'd just say index 0. So we start from 0, as with lists, and we give the name of the array, and then in square brackets put the index. So one-dimensional array, no problem at all. Two-dimensional array, we need to start from the outermost dimension, and we already saw a little example of that when we had a list of lists, I think last week, where we give the index of the outermost dimension and then the index of the next dimension as we drill in. So here, if we imagine we've got a two-dimensional array, so our outer square brackets, the pink ones here, that's effectively, imagine that as our list of groups, and we've got 3 groups. So what this says here is give me the second group, the one with index 1, so that's this one, and give me the third person in the third value in that group with index 2. So 0, 1, 2, that will give us the value 6. Okay. Same applies for a 3-dimensional array. You start from the outermost dimension, and we have to give in square brackets the coordinates of each dimension. So here, this would say start from the outermost, so that will be the pink here. So here we've got a list of groups within various departments. So this is maybe department A, this is department B, and each of them's got 2 groups. This says give me the second department, give me the second group, and give me the 4th individual within that group. So that'll give me this value here. You can see how this gets a bit difficult when you've got 100 dimensions. But don't worry, this isn't how you tend to refer to elements in that way. So just like with lists as well, we can use slicing. We looked last week at how we can slice lists to carve out a bit of a list in order to only return particular values from that list that we want. We can do exactly the same with a NumPy array. So imagine this is my NumPy array. It's a simple 2-dimensional array here. I've got basically two groups of numbers. So we can slice it. So if we slice it in this way, again, we use the square bracket notation after the name of the array. This says here, from the first element, remember it's starting from the outermost, so from the first group, give me back the first 3 values. So this is up to, but not including, the value at index 3. So that will be the ones with indices 0, 1, and 2. So in this case, that will give me back 1, 2, and 3. First group, so outermost dimension, will give us this, and then within that group, I want the first 3 elements. And then similarly, this slicing example here, we can use a completely empty colon. I think we looked at this last week for lists, I can't remember now. But a completely empty colon means, no, I don't think we did actually. This means give me from all lists, so in the outermost dimension, from both of these lists, give me back the elements from 1 up to, but not including index 4. So in other words, indices 1, 2, and 3. So from both lists, give me back the second, third, and fourth elements, basically. So 2, 3, and 4 from the first list, and 7, 8, and 9 from the second list. And that scales up to 3-dimensional plus arrays, just makes your head hurt a little bit more. So this, again, start from the outermost dimension. This says so again, imagine this is 2 departments, each of which has 2 groups with 5 individuals in each. This basically says from both of the outermost groups, give me back the first list in each, but only give me the first 2 elements of that. So that'll be 1 and 2, and 2 and 4. And similarly, just as with lists, we can use that referencing of an index to also update a value at a particular point in a NumPy array. So if we specify the coordinates, without doing anything else, it'll return that value to us. But we can put in an assignment operator using our equals and say, well, I want that, whatever value is there, I now want to update it to this. So this in our three-dimensional array says, give me back this first group here. I want the second list within that group, and I want the third element of that particular list. So that drills down to this value 8 here. And I want to update that with the value 999. And if I do that, then it'll overwrite this to 999. Now, it's important to say before I go forward that a lot of the things I'm now going to show you will use continue to use only 1 or 2 dimensional arrays, just so that your head doesn't hurt too much and to make it easier to understand. Okay, but all of these principles hold true regardless of whether your array is 1 dimensional or 200 dimensional. Okay, but it's far easier for you to understand if it's 1 or 2 dimensional because you can see it on the screen. So here's a little handy feature of NumPy. We can use the empty method of the NumPy of a NumPy object to create a new empty NumPy array. And that can be useful where we want to create a brand spanking new array, just like we create a new list that's empty, and then we can add things to it. This allows us to basically, if we use np.empty, we then pass in a list in the brackets. So open the normal brackets for, here are the inputs for that function, and the input I'm passing in is a list, and that list represents the shape of the array that we want, which is the length of each dimension. So that basically says, so this would create this empty array here, which has 5 departments, each of which have 4 groups, each of which have 3 individuals within that group. So starting from the outermost, the dimensions are 5, 4, 3. Okay. That statement there will create a brand new 3-dimensional array with those dimensions. And you can see it's completely empty, except you are probably sat there thinking, Dan, that does not look empty to me. It looks like there's quite a lot of numbers in there. Now, you're absolutely correct. So the way NumPy works is it doesn't strictly create an empty array. It creates an array with some garbage values in there. Now, you'll see, if you look very closely, these values are all extremely close to 0. All of these values have e to the minus, and then very high numbers, which basically means they're very close to 0. Okay, and they are basically pulled out from random junk that's in your computer's memory at the time. For all intents and purposes, just think of it as empty. Okay, you don't need to worry about that. It's just, if you're wondering why you seem to have things in something you thought was empty, that's why it is. But it is, for all intents and purposes, empty. You can, as we'll see in a moment, if you so wish, create a NumPy array that has all zeros in it. That might be more useful for what you're doing. But empty is slightly more computationally efficient. Okay, because it's just grabbing these garbage values. Again, for most of the things you'll do, probably won't make a huge difference. We also have a really neat function called arange in NumPy, which basically creates a NumPy array with evenly spaced values at any interval of our choosing. So let's say we wanted to create a NumPy array with the first value of 0 and counting up to 100 in intervals of 5. That single line of code will do that for us. We say np.arange, and then we give it 3 inputs: the starting value, which is included, the end value, which is not included. So we've had to go 1 higher here if we want 100 included, and the interval, which in this case is 5. So if we put that in, and I'll store it as something called 5's array, we'll create this new array called NumPy array called 5's array, which in this case is a 1-dimensional array, just to make it easier to understand. But again, you can make this a 200-dimensional array if you like. This is created with values going from 0 up to 100 in intervals of 5. I mentioned a moment ago when I talked about empty that there's an equivalent one called zeros, NumPy.zeros, which does the same thing as empty but makes all the values 0. And this works in exactly the same way. We give it the list of the dimensions that we want, and it will fill up. It'll create that that NumPy array for us with those dimensions, and it'll put the zeros as all of the values. Whenever we have a NumPy array, we're creating a NumPy object, a NumPy array object, and within that object are various attributes. One of those attributes that we can access is the shape. So a shape of a NumPy array basically stores the length in terms of the number of elements within each dimension. Okay, so this this zeroed array here, which we just created using np.zeros, if we were to call ask for the dot shape attribute, that would pass back this value 543, which basically tells us the length of the number of elements in each dimension, so 543, which is what we passed in to create it. You may, however, want to find out the number of dimensions itself, and we can use the ndim attribute for that. And if we use the ndim attribute on zeros array, it's a three-dimensional array, so it will tell us there are 3 dimensions. Now, you're probably thinking, well, this all sounds fascinating, but I can't really see a use for it so far. One of the great things about NumPy is it allows you to apply mathematical operations at huge scale to very large multidimensional arrays far more efficiently than you could do so otherwise. Okay, and fortunately, it's really, really easy to do that. Okay, and I'll show you just how easy it is to do. Let's imagine we've got a NumPy array, and it's a 2-dimensional array here, and we've got 3-dimensional array. We've got 2 departments, and each of those has 2 groups, each with 5 individuals. So we've got a nice 3-dimensional array. Now, I've kept it relatively simple here to fit it on the screen, but imagine there could be thousands upon thousands of elements in this array, in our 3-dimensional array. And let's imagine we want to double every single element within it across all of the dimensions. Well, we can do that really easily in NumPy and very efficiently. We just say, give the name of the array and say ×2. And there you go. It does everything for you. So it's really, and it does it really efficiently because it's using C code under the bonnet to do that. So we could have 3 nested for loops if we wanted to, that would go through and say for each element in the outer list, for each element in the middle list, for each element within the innermost list, element equals element ×2, and that would not only be more messy code-wise, but would be hugely inefficient compared to what you can do in this one line of code with NumPy. Okay, so here I've stored that as a separate NumPy array. It'll return a NumPy array, and you can either overwrite the same NumPy array, or here I've created a second NumPy array called doubled. So I'll have 2 arrays, one that's got the original values and one that's got these doubled values. And just to multiply everything by 2, literally name array ×2. That'll do it. We can also combine mathematical operations with slicing as well. So if we only want to do it to certain bits of our array, we can do that. So this here says for each of the second lists in both groups. So for both groups, for each of the second lists, I want you to, so it's a 3-dimensional array. We're specifying the coordinates of the 2 outermost dimensions. For each of those, I want you to double those only. Okay, so if I only wanted to double this and this, I can do that using this notation here. And again, very easy, just say that multiplied by 2. And again here, so rather than set it as a separate array here, I've assigned it what we call in-place updating, where it's going to overwrite those values in that same array. We can also perform lots of statistical operations in NumPy arrays really efficiently as well. We can find a single mean value across the whole array just by saying name of the array dot mean, and that's it. It'll give you the a mean across all of the values in your array really efficiently. Again, there's only 5 numbers in this 1-dimensional array here. Imagine millions of numbers. Okay. And so that you can see this works for a 1-dimensional array here, and in the second array it's basically taken a mean across all of the values here, If we don't want to find a mean of all values across all dimensions, we can be a bit more specific than that. So we can find means across different dimensions of the array. So if we said np.mean and then pass in the name of the array, and if we say axis equals 0, that means give me the mean across rows, i.e. in this case the two lists. So that would say give me the mean of element 0, the mean of element 1, the mean of element 2, etc. So here, if we can work this out. So that's saying the mean of 1 and 6. Okay, so that's going to be 3.5. The mean of 2 and 7. That's 4.5. The mean of 3 and 8. So what will get returned here is an array itself, each of which has a mean value. Or we could do it the other way around and say we want to take the mean across columns. That will give us axis equals 1, will give us that, which gives us effectively the mean of each row. So what's the mean of this group and what's the mean of this group? So here we get the mean of this group is 3, the mean of this group is 8. Again, think back. Let's imagine these are groups of individuals. The mean of ages here, pretty young group, but the mean of ages here is 3, the mean of ages here is 8. Okay. And again, as ever, you use the same syntax for 2, 3, 4, 200 dimensional arrays, whatever it may be, and the axis the value would simply increase. Again, don't worry if your head's starting to hurt. That's why I'm showing it to you using these simple, easier to understand arrays. We can also perform a dot product of two arrays of identical length. And we can do that really easily using NumPy. Some of you may be familiar with dot product, others may not. Basically, the dot product of two arrays is where we take the multiply the nth element of array A with the nth element of array B, and then we add up all of those multiplications to get a single answer. So, simple example, imagine we've got an array here that has the values 1, 2, and 3, and array B, which has the values 2, 4, and 6. To take the dot product of those, we'd say 1 multiplied by 2 plus 2 multiplied by 4 plus 3 multiplied by 6, which gives us a total of 28. Okay, and to do that in NumPy, we just say np dot dot, and then we pass in as the inputs the two arrays we want to take the dot product of. In this case, A and B. Simple as that. And you're probably thinking, okay, when would I ever use a dot product calculation? They can be really useful. They're particularly useful if you want to weight one set of values by another set of values. So as an example, you might, for example, build a geographic model where you want to weight, you'd have one array which represented travel times and another array which represented the number of people that lived at each of those locations. And therefore you could weight your travel time calculations by the number of people that live there, so that you don't skew your results by saying, okay, well we're placing too much emphasis on this one person that lives a long way away, which would be very different to 1,000 people living that distance away in determining where we might place our service. So things like that give it a little bit more of a practical flavour. We can also remove duplicate values easily from NumPy arrays. So the unique function, basically, if we call np.unique and then pass in the name of a NumPy array, it will just simply remove all of the duplicate values. So here it turns a two-dimensional array into a single one-dimensional array that has all duplicate values removed. So here we've got a duplicate of the number 5. So here it's just passed back a single one-dimensional array that just has just the one value, number 5. And we can also use it to remove duplicate rows or columns. So here we've got a two-dimensional NumPy array that has a duplicate row. It's got this 1, 2, 3 twice. Maybe we don't want that. We can call np.unique, pass in the name of the array, and then if we say axis equals 0, it'll remove duplicate rows. So then we'd end up with 1, 2, 3, 4, 5, 6, and this second one would have gone. And we could do the same with columns as well. So 1, 2, 1, 2, 4, 2, 3, 5, 3. If we call that with axis equals 1, this basically says, well, 1 is a duplicate within this group. So we'll just leave that as 1, 2. 2 is a duplicate in this group. So we'll just pass back 2 and 4. 5 sorry, 3 is the duplicate in this group, so we just pass back 3 and 5. Okay, are your heads sufficiently hurting? I suspect they are. Some of that will seem a bit odd. I promise you it will all make sense, and hopefully what you've seen, if nothing else, is that whilst the concept of a multidimensional array might seem a bit weird to get your head around, hopefully you can see that actually the commands that you use in NumPy are incredibly easy. I mean, just being able to take an array that has 400 dimensions and 10 million values, if you want to double everything, you just say that the name of that array times 2. That's how easy NumPy is to use. Okay, which is mostly what you're going to be doing with this. So anyway, let's stop at that point. After lunch, I'm going to show you an example of why NumPy is so important, and the significance of the speed difference that you get from more complex arrays. And you'll also have a chance to have a practice and NumPy exercise in your groups. But for now, go and take a well-deserved hour's break, go and have some lunch, and we'll resume at 1:30. Stop sharing. Oh, I've shrunk. Okay. Hi everyone. Oh no, I'm too tall. Let's try again. Hi everyone. Sorry, that wasn't very elegant. As I was completely lost track of time as well. So welcome back. I appreciate, and I'd just like to again echo Sammy's echoing of my comments before lunch. I am aware that NumPy is not the easiest thing to get your head round, so don't panic if you're looking at NumPy and thinking this has gone largely over my head. The key things to take away from it today are that it is a way in which you can work with large multi-dimensional arrays very efficiently, much more efficiently than without it. And that's important because when you come to do things like machine learning, you are dealing with large, vast multi-dimensional arrays. So that's why it's important. A lot of what you do, though, is just the odd thing here and there around the edges. You don't need to have really extensive knowledge of NumPy for a lot of what you're going to be doing this in this course. So don't panic about it. And as I say, as Sammy's pointed out, you won't use it I don't think use it at all in module 2, but if you do, it's tiny, or module 3, and it'll only be in module 4 you'll start to use it a bit. We're introducing it at this stage because it is an important library, but it's mainly to convey the kind of use case for it and get you used to some of the basics of it. The good news is that Pandas, when we cover that in a bit, will seem beautiful in comparison to NumPy. NumPy is definitely, I'd say NumPy is the hardest bit of these 3 intro Python sessions. Probably NumPy is the hardest, I reckon. Maybe object-oriented programming, although I think people tend to pick that up okay after we do because we've introduced the concept a few times. But NumPy is it's a bit weird to get your head around. So I just wanted to flag that up. So don't panic about it. It will come in time, but you don't worry if 6 months down the line you're still not fully understanding NumPy. That's fairly normal. So don't worry too much about it. I don't want people having sleepless nights tonight, waking up shouting multi-dimensional arrays, if you can help it at least. Having said that, I'm now going to finish off a little bit on NumPy, but the good news is there's no more sort of technical information to take in. I'm just going to do a quick demo before you go on to the exercise where you will try out a bit of NumPy, and I'm going to get you to work as a group to do that. But before we move on to that, I realise we should at least indicate why it's so important. By the way, I was just to say I was going to post in the chat just before we came back from lunch that there were a bonus 2 PSG points for anybody that correctly identified what game this was from. But I see Chris from Sid, I believe, has already beat me to it and already identified it was indeed Discworld 2. So well done, Sid. You've got 2 bonus points from Chris there. So well done, Sammy. Perhaps if you can add that into the into the spreadsheet. You see, knowledge of classic point and click adventures will get you a long way through HSMA, at least in terms of some points. Okay, so let me show you a bit of a NumPy speed demo. This is adapted from, well, largely nicked with some bits deleted from my colleague Tom, who developed this. It is available in your lecture examples folder, so you can run this yourself as well. But I'm just going to show it to you for now. So basically, the way this works is just a very simple demonstration of the speed difference between using a conventional approach like a conventional for loop to add up some numbers in this case versus using NumPy. Because I said one of the key advantages is that you can perform mathematical operations at scale and incredibly efficiently with very, very large arrays. So we're only going to use a fairly moderate size array here, but just something a little bit larger than you would have covered normally. And we're going to use a little feature called time it, which basically will automatically time the difference, or time how long each thing takes. So if you go to run this code yourself, incidentally, you can run. There's a couple of ways you can do this. You can either just run each bit, copying and paste each bit into the console. But if you're using VS Code, I'm not sure if Colab does it or not. I don't think it does. You'd have to put it in separate cells. But certainly, if you're using VS Code, Tom's included this little formatting thing here. These sort of weird little symbols. Basically, splits it into cells, which it makes it sort of somewhere halfway between a Python script and a Python notebook. But it means you can run each of these cells individually, and then you'll see these little buttons that pop up, so you can run each of these cells individually. So it's quite a nice little feature. So what we're going to do first, we're going to run this first cell here, which just simply imports NumPy. Oh god, no, sorry, don't worry about that. All that stuff up there. That's for 5C. Don't worry, it'll all make sense when you come there. I forgot I'd left it there. So yeah, 5C. No, not 5C. So I run that cell. I've imported NumPy. Then what we're going to do is we're going to generate two different constructs. So the first is that let me just zoom in a bit so you can see this a bit better. The first here is we're just going to generate a standard Python list like the ones you've been using. And it's going to this command here where we use range and then we input a number in the brackets and then we cast it as a list. Basically, that's a way to generate a standard Python list that will consist of numbers from 0 to 999,999. So 1 million values, basically, from 0 up to just before a million. So that will create a standard Python list like you've been using before. This line of code will do exactly the same, but it'll make it a NumPy array. So we use the arange command, which I showed you before lunch, and we can if we just specify a number, it'll default to start at 0 and increment by 1. So you don't have to specify those things if you don't want to. And so that will these two things basically will give us the same thing but in different forms. One will be a normal Python list. One will be a NumPy array, and in both cases, they will be numbers from 0 up to, but not including a million. So then what we're going to do, once we've run that, is to add up all of the numbers, and we're going to try that in the Python list first, and then we're going to try it in the NumPy array. And we're going to use this, this is known as a magic command, this percentage sign, and we're using an external command called time it, which basically allows us to time a piece of Python code, and it'll tell us how long it took. The magic command, you'll learn more about those a little bit later, but it basically, you don't use them that often, but it means you kind of temporarily step out of the Python environment to do something a bit external to it. In this case, run the time it command. But don't worry too much about that. Basically, this will time how long it takes, and we'll do it first on the by adding up all the numbers in the Python list, and then all the numbers in the NumPy array. It'll be the same result, and it won't even print the result. It's just going to time how long it takes to add up those numbers. So let's try it first of all with the standard Python list, and it'll output. It actually does a number of runs to test this, and it'll output in either milliseconds, where it'll have a little ms, which is 1,000th of a second, or even microseconds, which has got the mu symbol here, and that's a 1/1,000,000th of a second. So an order of magnitude smaller, shorter in time. So, okay, so we've tried the Python standard Python list. It took 12.4 milliseconds on average to add up those numbers. Okay, let's now time how long it takes for NumPy to do the same thing. Now, bear in mind, this is a trivial example even for NumPy, even for a Python list of adding up numbers up to 1,000,000, but this will give you an idea of the scale of difference. So standard Python list, 12.4 thousandths of a second. NumPy, doing exactly the same thing, 125 microseconds, 125 millionths of a second to do exactly the same thing. That is a huge difference between those two things. Now, as I say, if that's what you need to do to add up some numbers between 0 and 1,000,000, well, I'm sure you can probably wait 12.4 milliseconds. But the point is that if we scale this up to where we've got huge arrays of numbers with hundreds of dimensions, you can see which one is going to be far more efficient when actually we're not just sat here for half a second or less. We are potentially having to wait some time for a process to complete. This is why NumPy is so important for the kind of thing that you will be doing, and why it's such an important structure, because it transforms the speed at which you can do these mass scale operations. So, as I say, feel free to play around with that in your own time as well. Also, obviously, this is slightly computer dependent. It may take longer on your computer. Mine's a bit faster, but the scale of the difference should hold up. Okay, so let's move to the thing you've all been dreading, doing an exercise on NumPy. So here it is. You're going to have half an hour to do this. Well, I'll give you till quarter past 2. I want you to work on this as a group. Now, I think from memory, let me just zoom back out. Oh no, too far. Is it? Oh, sorry, it's the zoom bar's in my way. No, it's that one, wasn't it? Yeah, okay. I just showed you the solution, so hopefully you didn't see that. So let me open it up. That'll be safer. Lecture example. No, this one here. So exercise 3. This is the one you need. There are just 2 tasks to undertake for this particular exercise, and I want you to work on both of them in your groups as a group, because this is a little bit harder for people to get their heads around, so I don't want anybody feeling lost with this. So your first task is you've got to create 2 NumPy arrays, one with all the odd numbers from 1 to 999,999, and one with all the even numbers from 2 to 1,000,000, and I want you to calculate and print the dot product of those 2 arrays. And then the second task is a bit more involved, in which you've got a training provider who has 10 centres, each with 1,000 students that have taken an assessment. I want you to randomly generate some scores for each student in the centre and represent them in a NumPy array. Each score should be between 0 and 1, representing their percentage achieved on the assessment. Then I want you to calculate the mean score achieved by students at each centre. And once calculated, the mean should be converted into percentages, and then rounded to 2 decimal places, which should then overwrite the same array of percentages. So there's quite a few instructions there. Now, the key thing to flag up about this is that in order to tackle that second task, you're going to need to use some NumPy functions that I haven't taught you. Okay, and I've done this deliberately. This is a really important skill to learn when you are coding. There is no way that even if we ran this course for 2-3 times the length it is now, that we could teach you everything you'll ever need to know. That all of the time as coders, you are going to be looking things up. You'll be looking things up a lot of the time just to remind you of things you have done before, but you've forgotten. I do that all the time. I even use my own HSMA materials to remind me to do of certain things, including things in NumPy and Pandas, because I know I've covered them in the teaching. But there will also be circumstances where you need to know, okay, well, I want to do this. There must be a way to do it, and you look up how to do it. So that's a really important skill to learn, and particularly, I think, with something like NumPy, where again we are just scratching the surface, much as we are with Pandas, but these are important packages. Really important to get you into that habit. So this is going to be a bit of practice for you to go out and try and look for a way to do this. I've given you a bit of a kind of starter for 10 here. There's those of you who are new to coding, Stack Overflow is a widely used resource for all coders and has a lot of coding questions on there. To be honest, just searching on doing a search in your search engine of choice is a valid option. You could, of course, use some form of AI, and just be careful. They are very convincing, and often they're right, but sometimes they're very convincing and they're very wrong. So just be aware of that. But for some questions, they're very good. And plus, you can also, there's the official NumPy documentation if you want to look specific things up. Although that's probably not the best starting point for this. It's huge. There's a lot in there, but it's very good if you need to look up, you need to use a particular method in a certain way and want to see what other options you can use for that particular method. So that's a good way to do that. But however you want to discover how to do these things, then that's entirely up to you. But you can have half an hour now, so to 2:15, I'll put you into your groups and have a go at this. But do work on both exercises as a group. Okay, let me stop sharing. I can move back my bar. There we go. Hi everyone, welcome back. So apologies, I only managed to get around to like 2 rooms and was trying to frantically try to resolve an issue that I wasn't aware of until this came out. And yet another reason to hate Windows for data science. So well done to those of you who identified both the problem and posted the solution to it. And there's some points for your relative groups for doing so. Yeah, basically, we first encountered the problem when we saw somebody on a Mac calculating a very different dot product to those of us who were using Windows, and it appears and it's significantly different. And indeed, if you were to calculate just the final bit of the dot product calculation, which would be the 2 highest values multiplied by themselves, let alone adding them to everything else, you'll see the Windows answer is actually smaller than that, so can't possibly be correct. And it's basically due to, as hopefully you've seen in the various conversations on Slack, if you're using a Unix-based system like Mac or Linux, you will get the correct answer because it is by default using a 64-bit integer data type. And obviously you're doing a huge calculation here that needs more memory to store that number. Whereas Windows, in its infinite wisdom, despite being 64-bit only in terms of its operating system for years, still defaults to 32-bit integers. So you can override that, and thank you to Sean and Zylog, who posted this, which I've reposted in the class Tannoy. If you add dtype equals int 64, you can do that on either operating system, and that will ensure that it's correct. But you don't have to on a Unix one. You do on Windows. So another reason to hate it, which we are going to pass back to our colleagues who will love this. Just another reason not to use Windows for data science. So there we are. Aside from that slight confusion that really confused all of us for some time, Sammy and I were just talking. It was really nice to see. I think we got the sense that you were probably surprising yourselves a little bit by that exercise. I realised, the lecture before lunch seemed quite heavy. There was a lot of complex stuff in there. But from what I saw, actually, you were getting on really well trying to solve this. And even those that didn't quite get there, and then you were on absolutely the right track. So keep plugging away at it, because I think you're better at NumPy than you think. I will, in fact, I'll do it now. I'll post the solution to exercise 3 now. I just want to make sure that I have saved this. I've corrected the solution to include the data type int equals 64, and I've also put in a little comment there, partly to remind me next year that that's an issue. So I'll pop that in the tannoy now before I forget. That was exercise 3, wasn't it? Exercise 3 solution, where are you? Sorry. Completely unorganised now, I've been doing this. There we go, right. So that's posted in if you want to check that out. But if you were most of the way through it, I'd advise trying to finish it off yourself before you have a look at the solution, as ever with this stuff. Okay, let's move on. Share and here. Oh, nope, that is the right one. Close that down. Right, let's talk about pandas now. So hopefully this will be a bit lighter than NumPy. Equally important package, but far more approachable and far more used to the kind of thing that you are used to in many of your day jobs, I would say. So let's talk about pandas, and of course by pandas I mean the beautiful and glorious and intelligent open source Python library that provides powerful data structures and analysis tools. Indeed, I always think you can judge the level of geekiness of a person by saying I love pandas and seeing if they reply me too, and also NumPy. Maybe not NumPy, but see if they mention another data science package. So what is pandas? Well, pandas is basically a very large tool, a bit like NumPy in that it's very powerful for manipulating data in large arrays, unlike some spreadsheet software that I could mention that you probably are all using, and it allows for indexing of data, and NumPy and Pandas are often used together. You'll often import both of them and they will be used hand in hand, and NumPy would tend to use that bit for any sort of mathematical functions, the kind of numeric operations, and Pandas is used to kind of manipulate your data. And as with NumPy, we have an alias, a conventional alias that is used that will make sure that you're not frowned upon by the Python community. So with NumPy it was NP that we imported as. With Pandas we import it as PD. So import pandas as PD is your standard alias under which you should import pandas. So one of the most useful structures in pandas is something known as the pandas data frame. And basically a data frame is like a table which has different columns, and those columns have names, and each of those columns represents a different data field. So it's you have sort of data in various columns, and then each row essentially represents an entry in your data, an individual patient record or whatever it may be. So this is very familiar to all of you, I would have thought. This is a bit like an Excel table, but only much more powerful. I cannot emphasize enough the stark difference in what you can do. So if you want to create a new pandas data frame, we can do so in one of two ways. We could create a brand new data frame and then build up the data frame manually, and sometimes you might want to do that. Or you can read in existing data from a CSV file and dump it straight into a pandas data frame. Now 99% of the time, for the sort of thing you will be doing, you will likely be doing the latter. There will be times during the training where you won't do that and you will create a little manual one, but most of the time for the situations where pandas really comes into its own, you will be reading in a CSV file and turning it into a pandas data frame. So we're going to focus primarily on that. And the good news is that's incredibly easy to do. And I did mention this morning that when we were looking at opening CSV files and you were reading things manually into lists, how much easier it is to read it into a pandas data frame. And that's because pandas has a really nice little function that will automatically read in the CSV file and dump it into a nicely formatted data frame with all of the column headers intact as the column headers in the pandas data frame. And it does all this in one line of code. And if you don't believe me, here you go. This is a CSV file, inputdata.csv, much as we had earlier. This is the one line of code that will turn that into that. And now suddenly you've got a Pandas data frame, which has got all the nice column headings and it's all correctly formatted. So what we're doing here is we're calling the read CSV method of Pandas, and we simply pass in the name of the file, and that's it. And that will store it into a data frame, which I've just called DF. As a common abbreviation we use for Pandas data frames, but obviously I can call it anything I like. You'll also notice though here that we've got an extra column of numbers at the start. Now this is known as the index column, and whenever you create a new Pandas data frame, it will automatically get added this extra column that wasn't there in the original data. And that's because just like a database, and a number of you used SQL, used to using databases, you will know that in a database you have to have a unique identifier for every entry so that you can reference a particular record by that unique identifier. Pandas is the same. You have to have a unique identifier, and so it includes its own by default, and basically it just starts a count from 0 and counts up from there, and that it calls that the index. And in some cases that's fine. That's all you need. All you need to use. But it might be that in your data you've already got something that would work as a unique identifier and would be better placed as the index, because then you could refer to it. So patient ID might be a really good example of a unique identifier. Now, you need to be very careful that your column does genuinely have unique values. If it doesn't, Pandas will check and it will fall over if you don't have unique values. And you might, although patient identifier might be unique, bear in mind the data you're reading in might have multiple entries for that unique identifier. So you need to make sure for every row there is a unique identifier if you're going to use something within your data. But assuming for the moment that in our data here, patient ID is a unique identifier for each row, then let's say we want to use that now as our Pandas data frame index. When we read it in, we can actually pass in this argument here to say index col equals, and then give it the name of the index column, and that will be whatever is in the header. Okay, so that's what Pandas will use as the column names by default. But as I say, we'll check, so do be careful, and you will run into problems if you've got multiple entries there. Okay, so now we've got our index set up, and in our case we're using our patient ID that we've got in the data. We can select certain rows and columns in our data frame, and this is known as indexing in Pandas. So you'll hear a lot about you need to index something in Pandas data frame. What that means is I want to select a certain column or a certain row. And so let's have a look at some examples of indexing in action. So let's say we wanted to retrieve a particular column from a Pandas data frame. Then let's say we've got in our data name, flu vaccine, age, and county. Let's say I wanted to grab the name column. I simply give the name of the data frame, and then open my square brackets and provide the name of the column I want. I pass that in as a string because they're stored as strings, the column names. So in this case I put df name, and that will pass back the name column. You'll notice also that the index is always returned to, so that always gets passed back even if you didn't ask for it, so just be aware of that. We can, as well as just retrieving one column, we can actually retrieve multiple columns at the same time, and we do that simply by passing in a list. So here we have a kind of nested square bracket, so we have the outer square brackets, and then inside that we pass in a list of column names. So here I want name and county, so that will pass me back from this data the name column and the county column. Really easy. We can also get a specific row, and we can do that by providing the index value. That's why it's there. And so we've set our index to be the patient ID. And so we can use the lock method, which stands for locate. And if we say df, so the name of the data frame, dot, and then the locate, LOC, the locate method, and then open our square brackets, and then provide the index value that we're trying to look up. So in this case, if I provided 90154, well, that's Alfred in Devon, and so that will bring back this entry: name Alfred, flu vaccine no, age 71, county Devon. Okay, really easy. And again, I can retrieve multiple rows, much in the same way I can retrieve multiple columns, by doing the same thing. I pass in a list of the indices that I want returned. And so in this case, I've passed in 2 indices, and so I get these 2 patients back as a data frame. I can do both at the same time. I can say I want these particular rows for these particular records, and but I only want to see these columns. I don't need to see the whole data frame. So here I want the records for these 2 patients, but I only want to see their name and county. And again, out pops a little mini data frame which has that information. And it's important to state, whenever it passes it back, it's passing back a data frame itself. We can also select rows in a data frame based on conditional logic, so we can check certain criteria and only return things that match that criteria. So, for example, we might, in our data frame here, we might want to retrieve all records where the county is Cornwall, so all patients who live in Cornwall. And to do that, again, we use df.log, and then in the square brackets, we put in our conditional statement. So this needs to resolve, whatever statement comes in here needs to resolve to a Boolean, needs to be a true or false, essentially, that this would resolve to. So here we've got a comparison operation that checks whether the county, so df county, so that refers to the county column of this data frame, whether that is strictly equal to Cornwall. So therefore it'll only then return patient records that are where the county is Cornwall. We can also do things like check where the age is greater than or equal to 60 using exactly the same format. We can also combine multiple conditions, much as we can with conditional logic, although there's a slight difference. So we can check, for example, let's say we want to retrieve all the records from patients who are in Cornwall who are aged 60 and over. Then we need to check both of these conditions, so that the county is Cornwall and the age is greater than or equal to 60. However, note the slight difference here. In a conditional logic, in an if statement, you can use the keyword and, A-N-D. You cannot do that in df.lock. You have to use the ampersand character, not the word and. It will fall over. Or at least it used to, unless I changed that. So you do need to use the ampersand character here if you want to use an and. So this says only return entries where both of these things are true. Okay, that the county is Cornwall and they're at least 60. And as you might have guessed, because we can use and logic, we can also use or logic as well. And here we say we may want to grab patients who live in Cornwall or those who are at least 60. So grab me everyone from Cornwall and people that live elsewhere only if they're 60 or over. Essentially, that's what that's saying. Again, you can't use the or keyword. Instead, you have to use pipe. Pipe is one of those symbols that you look at on your keyboard and think, oh, I didn't notice that was there, that we used to use quite a lot in the old days, and it's still used if you use sort of Linux shells and things like that. It's a really handy little character, but for the rest of you, look for that vertical bar. That's the pipe character, and it's probably one of the very few situations where you will use it in your daily lives. But basically this means or in this context. So either this needs to be true or that needs to be true, or both. We can also add additional rows and indeed columns to a data frame. So to add a row, we have to specify the values for all of the columns in this new row, which makes sense. If we had an Excel table and we needed to add another patient, we'd have to give all the information for all the columns that we've got. And similarly, to add a column, we have to specify the value for that column in all the rows. So to add a row, we would specify the index value for the new row and it would be, if it doesn't exist, that would essentially add to the row. So just like where we're referencing in a list or something, or another, like, sorry, a dictionary is a better example, where we provide an index value, a lookup value that doesn't exist, and it will then create it. We do the same thing with a data frame. We provide it with an index value that doesn't exist for our new entry, and then we need to give it all of the values for all of the columns, apart from obviously the index. So here the index column is one of our columns. If it's a separate pandas, the separate pandas index that it added, you'd have to specify patient ID as well in this list. But we just add that as a list. So here I've just specified I could have done that in one line, but here I've specified the list of entries for each of the columns. So that'll be the name, whether they've been vaccinated, their age, and the county. Be careful though, you can of course accidentally overwrite a row by doing this. If you give an index that already exists, it will overwrite that row with whatever information you give, so just be aware of that. To add a column, we need to do the same thing, but we've got to add in all of the values for that new column for every entry that we have. So here, if we wanted to add a new column that indicated whether they were admitted or not, then we would have to add a yes or no entry in this case for every single patient record we've got. Now, I've only put 5 there. There's actually over 30 in the CSV file. I've just done this here because I was not going to sit there and type out 30 entries. But you get the point. You'd have to have a list that contains the values for every one of those rows. Another way, though, of adding to a data frame is to join 2 data frames together to create one bigger data frame. And we can do this using a method in Pandas called concat, as in concatenate. So let's imagine we've got 2 data frames here. We've got data frame A and data frame B. Data frame A contains Dan and Sammy, who are both trainers. Data frame B contains Mike and Tom, neither of whom are trainers. If I wanted to join these into one large data frame, then I can use the concat method. So I say pd.concat, and then as my inputs, the first input would be a list of the data frames we want to smash together, and you can concatenate more than 2 if you wanted to, although I'd advise being careful with that. So a list of the ones that you want to smash together, and then an axis value, which would determine how these things get joined. Are you joining by adding rows, which we are in this case? We want to add, well, essentially we're building from these 2 data frames of 2 rows, we want to make a data frame that has 4 rows, or are we adding columns to it? But in this case it's rows, we say axis equals 0, and then that will create one new data frame that I've called data frame C that contains both. Now you'll note in this example, we have entries with duplicate index values. We need to, if we were doing this for real, we need to do something about that, because, and this, it depends how you're smashing things together. It may well be for what you are concatenating, they've got their own index values that are not the standard sort of pandas ones. But if you're putting together 2 pandas data frames that have just the standard pandas index, remember it will just start from 0 on each one. So when you put them together, you will have 2 entries with an index of 0 and 2 entries with an index of 1, and it does allow that in this way. And I believe, because I think I tested it, if you try and look them up, it'll return both values, I think. From memory, I think it returns a list of both, but I might be wrong. Again, try it out. But generally speaking, you want to avoid that. So you should have a unique entry, even though Pandas allows you to do it here. You should then correct it and create a new index. Pandas also allows us, as well as adding to it, we can drop things from it as well, remove things. This is known as dropping in Pandas. We can remove columns and we can remove rows. So to drop a column, I'm showing an example of dropping a single column here, but it's exactly the same syntax for multiple columns. You just pass them in as a list of column names. We use df.drop. We pass in the list of column names we want to drop, which is just one in this case, the name column, and I put axis equals 1 to indicate that we are dropping a column as opposed to a row. Now you'll see in this example here, I've dropped name and then I've stored the resulting data frame. Remember, it'll pass back a data frame as a different data frame. I've called it df no names. This is normally what you want to do. Normally, when you're playing around manipulating your data, you can either change things in place, i.e. change the original data frame, or you can create copies of that data frame. Generally speaking, you'll probably want an original that is untouched that you then start manipulating, and you may do various manipulations, but you'll end up with a few, possibly a few different versions of that data frame that have this one has the name dropped, etc. That makes it much easier if you then need to go back and do some other analysis and you need the name. Otherwise, you've got to go through the whole process of reading it back in again, okay? Because you've dropped name from the data frame. So if you've done that from the original, then you're going to have to read it back in. So just be aware of that. And there's two ways you can, if you did want to genuinely drop it in place, i.e. change the data frame as it stands, then you can either overwrite assign it to the name of the data frame. So I could say df equals df.drop, and it would overwrite df with itself but with name dropped out. Or you can add in an argument here where you say in place equals true, and that will specify that you want the change made in place. And then you don't need to do the assignment bit. So you could just have the, I was about to put my hand over the screen, you wouldn't see that. You only need the right bit of this equation if you did that. So as well as dropping columns, we can drop rows as well. And as you probably would guess, we drop a row by specifying the index or indices. Again, we pass in a list of indices if we want more than one dropped. And that would then drop the row that has that particular index. So Pandas allows us to quickly count the number of values for any categorical data that we've got stored within our data frame. So let's imagine, so we've got some categorical data in our data frame here. So we've got name, flu vaccine, age, and county. Flu vaccine is categorical, as is county. Okay, so flu vaccine either belongs to the category yes or no. County belongs to one of three categories: Cornwall, Devon, or Somerset. And so we can use Pandas to automatically get some counts for categorical data. It's really useful. So all we do is we specify the name of the data frame and the column we want in square brackets. So in this case, flu vaccine, and then we say dot. And then value underscore counts. We call the value counts method on that column. The column in itself, so just to explain a little bit, the value counts is a method of a data frame object. We're calling this on the data frame object, but the column of a data frame is in itself a data frame object. And that's something a bit weird to get your head around, but this is what I keep saying about when you remove things and add things, what gets passed back is in itself a data frame. So we're calling the value counts method of a data frame object, and that single line of code is all we need, and it will automatically count up. Yep, there's 18 that have a value of yes and 16 that have a value of no. And similarly, we could do that for county, and it would count how many in Cornwall, how many in Devon, how many in Somerset. You can also combine that with various conditional logic. So, for example, you could say, I want the value counts for the flu vaccine, but only for those people in Cornwall. And so we can put in our give me the data frame column county, but only where the entry matches Cornwall. And then for the flu vaccine column, I want you to count the values based on that. So rather than, so the difference between these two, if we look carefully, this one says, for the flu vaccine column, count up the various categorical values. This one says, for the data frame that would be created by looking at where the county is Cornwall, give me the flu vaccine column and count the number of entries for each value. And so we can see here 8 not vaccinated, 7 vaccinated for Cornwall. We can also create, and this is quite natty if you're used to using Excel and you've probably used pivot tables before, we can create pivot tables really easily in Pandas. And I will point out far more computationally efficiently than in Excel, particularly for the large kind of data sets you'll be using. Again, just to hammer home this point, the resultant pivot tables that you create will themselves also be Pandas data frames, and so you can manipulate and work with those pivot tables in exactly the same way as with any other Pandas data frame. So let's imagine for our data frame we want to look at the average age by county. Okay, really easy to do this. Again, single line of code. I've just spread it over 4 lines so I don't go over my 80 characters. And here I just say pd.pivottable, and then within that I've passed in 4 arguments. I've said data equals and then the name of my data frame. So that's the data of the name of the data frame I want to create the pivot table from. The column that we want to use as the index, which in this case is county, because we want to look at age by county. The values upon which we want to look at the other side of the pivot, and what we call the ag function, which is basically what kind of information do I want back. So here I want to look at average. So this is looking at the mean age by county. This says give me the mean. I want the values I want you to take the mean of are the age, and I want that by county, and I want it in this data frame. That 1 line of code will generate this pivot table here, which, as I say, is in itself a data frame, and it tells us the average age in Cornwall is 60. Cornwall and Devon is almost identical, whereas Somerset seems to be a bit younger in this completely made-up data set. You'll also notice, and I keep mentioning it, this is in itself a data frame, this pivot table. You'll see now that county is now the index for this data frame. So the pivot table data frame, the index is county, and that should make sense. We told it that's what we wanted the index to be. So because the pivot table is in itself a data frame, we can do exactly the same with the pivot table that we can do with any other data frame, including the data frame that we used to generate the pivot table. So we could, for example, retrieve the mean for Cornwall just by specifying the index. Remember, county in this data frame, the pivot table, is county is now the index. So I can give the .lock command. I can provide Cornwall as the index, and it'll return the entry for Cornwall. You probably want, if you're doing a pivot table in earnest, you probably want to have more than one point of comparison, and to do that it's really easy. You just pass in your values as a list. You're probably getting the hang of this pattern now, but if I wanted to look at, for example, average age and average number of emissions by county, I just pass in age and number of emissions as a list to the values argument. Pandas also got some really nice features that allow us to drop duplicates within it. We can easily drop any rows where all of the values, other than the index, it ignores the index has to be unique, but ignoring the index, where all of the other column values are identical, if we want to remove those, we can do that really easily. So let's imagine we've got this data frame here. So I've just set up a little manual data frame here, just a very simple one, just so to show this. So I've got, and the way I've done this is by setting up a dictionary where the key is the column name and the value is a list of entries against that column name. You can create a data frame easily from a dictionary in 1 line of code just by passing it that dictionary, and it will automatically then set this up as the column header, and this is the list of values for that column header. So here we've got some patient IDs, we've got some ages and some admissions. Now we've got 3 records in here that are duplicates because they've got the same information across all the columns, ignoring the index. They've got the same information across all of the columns for the same patient. Here we've got patient 105, 876, admissions 3. That's also duplicated down here and also down here as well. So we're not using patient ID as an index here, just to point out. So if we wanted to drop the duplicates, we can do that in one line of code just by giving the name of the data frame and calling the drop duplicates method on it. And again, here I've stored that will pass back a data frame, and the data frame that's passing back is the one where the duplicates are gone, and I'm going to store that in its own data frame that I've called no duplicate omissions data frame. So it turns this into this. And by default, Pandas will keep the first duplicate and it will get rid of the rest. Okay, so in this case, it's kept index 0 and it's got rid of 2 and 3. Sometimes, though, particularly for the kind of data you're looking at, you might want to keep the last entry, because that might be, if it's in chronological order, for example, that might represent the last encounter from the patient or something like that. And you can do that very easily just by calling exactly the same method, but we just pass in an input here and we say keep equals last, and that will keep the last one instead. So if I do that on this, you can see it's kept entry 3, this one, the last duplicate entry, rather than the one with index 0. Now, that's all well and good, I hear you say, but how likely is it that we want to use that particular definition of a duplicate? It might be we don't need all of the values to be the same. It might be that there's just a certain one that, for our particular data, we would consider it a duplicate. So let's imagine a slightly altered version of the previous table, in which we have updated. So we've still got patient 105 appearing in 3 entries, but this time the third entry for patient 105, their admissions has gone up to 4, and it might be that what we want to say is, okay, we want to remove any duplicate entries where it relates to the same admission. So therefore we only want to keep things where the number of admissions changes. So 1 entry per number of admissions. And we can do that really easily as well. So this piece of code here will do the trick. So again, we call the drop duplicates method, but this time we pass in this argument here where we say subset equals, and then we pass in a list that has the columns that we need to change in order for it to not be considered a duplicate. So in this case, because it changes between between index 2 and index 3, the number of admissions goes from 3 to 4, then it will keep 0, although we could have kept it, if we just said keep last, it would have kept 2. But by default, it'll keep the first one, so it's kept 0 here, and it's also kept reference index 3, which is presumably where the patients then had another new admission. We can also sort values really easily in Pandas. Let's imagine we want to sort our original data frame that we had by age and then by patient ID. That line of code will do it. We just say the name of the data frame dot sort values. We pass in these inputs. So we say by equals, and then this is the list that we wanted to sort by, and it'll go from element to element, sorting it in that order. Now, I've only got to pass in age here because Pandas will automatically sort by patient ID. So if you need it sorted by patient ID, you don't have to, and that's, Pandas will automatically sort by index. And in this case, patient ID is our index. Because patient ID is our index, we don't need to specify that, because Pandas will do it it'll automatically sort by that anyway. So it will sort by age and then by patient ID. And you can see I've used the in place equals true here, so that it'll automatically update the data frame itself. So now DF has been restored as this resorted data frame here. There's a few other neat little features that are worth mentioning as well. You can give the name of a data frame and say .describe, and that will give you a really nice overview of all the numerical data in your data frame. We can also see the first X number of entries in our data frame using head. So if you say the name of the data frame .head and then put in a number, it'll give you, in this case, 5. It'll give you the first 5 entries in the data frame. You can do that the same from the other way as well. So you can say .tail. That will give you the last 5 entries of the data frame. You'll notice in VS Code, when you print a data frame, it won't show you all the data frame. In fact, I think by default it shows you the top 5 and the last 5, and it will do that automatically. But if you want to look at a particular number of values at the start or end, you can do that. You can make all of your numbers in a data frame a particular type. So let's imagine we want to turn all our numbers into floating point numbers. We can say the name of the data frame as type and then pass in the type, in this case float. That will cast everything as a floating point number. And we can really easily take the average of a column in a data frame. Really easily, we just give the name of the data frame, the column name .mean. That's it. That will give you the mean for that column. And you can do the same with standard deviation and all sorts of other stats that you can run on pandas. Okay. Any questions, Sammy, about any of that?
So one of the main ones that's come up is people wanted to check for things like filtering down the county to Cornwall. Is there a particular difference between using .loc and not using .loc? So with both of them working as a way of doing that conditional filtering, is there a particular benefit to using .loc?
Well, it depends on. So you have to use .loc if you are if you're referring in this way where you've got a particular condition. So I'm not entirely sure I understand the question. Sorry.
So I think basically if I'm just trying to think the best way to describe it. So basically, in this example, sorry, if you go back to the previous one. So in this, in this example, if we got rid of .loc, then the code would still work. So the filtering would still work without .loc there. So some people have who've used pandas previously have learned it that way, and would just, if there's any particular difference for any reason to use .loc instead.
I didn't know you could do that. So that's just the way I've always done it. So no,
Okay.
none that I'm aware of. Other than that's how I've done it, but yeah, if both ways work, I mean, be careful, pandas. Things suddenly just stop working, so
Yeah.
it might be that there's one method that's preferred. I don't know offhand.
Yeah, I think I'm also not aware of any particular reason for using .loc, and I learned the other way. So I think it is one of those things about probably at a certain point in time, someone in the pandas community started recommending one over the other. So
Yes.
yeah, either should be fine. And you may just find that one sticks in your mind a little bit more. I'm also just quickly checking. Or Chris has put some nice explanation in the chat by the looks of it. And sorry, I'm just quickly checking if there's any other urgent ones. I would just shout out as well. I'll put in the class tannoy a couple of quick extra tips and about merging. So there were a few questions that came up about merging and concatenating, and for example, whether you need to be specifying a column. So I'll just put a link to the .merge function, because that, for those of you coming from SQL, that will probably feel a bit more familiar to the kind of joins you're used to doing, and that's just a useful one to be aware of as well.
Cool. Yeah. No. Thank you. So I think we've got a hand up.
Oh, sorry, yeah, Amaya as well. I've just realised that one there. Amaya, do you want to shout that one out? That might be easier.
Yeah, I was just kind of with the as type and the like describe functions, what happens if there's a column that's not numerical? Like, do they break, or how does the well, I assume the as type, does it just ignore the non-numerical columns? And what does describe output for a non-numerical column?
From memory, I think as type ignores non-numerical columns, I believe.
Okay.
I need to check that, or you can check it. Sorry, what was the other question?
The describe function, like what output does it have for non-numerical columns? Does it just also ignore them?
Yeah, so it won't fall over. It might output nan, which is not a number. So if you see capital N, lowercase a, capital N, that you'll see that quite a lot in pandas. That means not a number. So you may see that for the describe. Although again, I'm not. I think it would have to be. I think nothing else would. I think it'll come up as a nan value. I think if you cast everything as like a float, I think it automatically ignores text data. I believe. I'd need to, but check it.
Okay, I'll give that a go. Thank you.
No worries. Cool. Okay. Right. In which case, we'll move on to the exercise. Hopefully, you found that a bit more relatable than NumPy. And Pandas is a lovely package that you will use a lot, and is really friendly, I think, to use and really powerful. Which is really cool. So we're going to take a 10-minute break now. Then you're going to work in your groups for how far? I don't know how far behind. Are we behind, Sammy? Do you know?
I am not sure. I will double check after
Okay.
this, and I'll update the yeah,
Yeah.
I'll have a look.
I tell you what. Let's say half an hour. We can always change it. So what we'll do if you take a 10-minute break to 1:15, then work in your groups for half an hour. Oh yeah, we must be behind because we've got the oh blimey, yeah, okay. I'm just wondering whether okay, we'll call it half an hour. Let's see how quickly you get through it. If people generally finish a bit quicker, we'll bring you back a bit quicker. But if we can shorten the break to 5 minutes, although if you need to take a bit longer, please do. And then we'll resume at 3:40. Does that kind of work for people? Have a go at the Pandas Pop Exercise 4. There's basically 8 tasks, but they're much shorter than the ones you've been used to. They're like 2 lines of code each. But work on it as a group. And basically, this you're going to be using a data set that we are going to be using later in the course. It's known as the Titanic data set from Kaggle. And it basically contains data, real world data about passengers on the Titanic and whether they survived or died and all sorts of other information. And we use that in Module 4 to build some machine learning models to see if they can predict whether a passenger is likely to survive or die. And it's commonly used as for training in machine learning. So have a go at that together. So take a 5-minute break now, and then we'll have a go in your groups at exercise 4. And we'll resume at 3:40. Brilliant. Hi everyone, welcome back. Managed to get around to a couple of the groups. From what I saw, I think I get the impression people were probably a bit more comfortable with that than NumPy, which would make sense and is usually what we see. So hopefully you saw that Pandas is quite easy to use. Actually, it's not too bad at all to get used to it, and is really powerful. And hopefully you found that quite an interesting exercise in terms of exploring some of the Titanic data that you're going to be using in Module 4, which you'll be using again and again and exploring different methods for using that data. So nice to get you a little sort of primer on using that. So one thing, I've put the solutions in the class Tannoy. I just want to flag up as well that Sammy has posted in one of the sorry, I can't remember which channel it is. Sammy, which channel is it? Sorry.
So I have pinned it to the top of the Coding Clinic channel for now, but I will post it in a link in some of the other channels later today as well.
Great. Okay. So yeah, Sammy's been putting together a bit of a repository of all the fantastic things that people have been sharing, like cheat sheets and little guides and optional resources. So do check that out, particularly if you're struggling with any of this, sometimes, having somebody else explain it, or looking at it in a different way, or just having a little cheat sheet to remember certain things can be really useful. So please do check out those resources, and thank you to everyone who's sharing that stuff and continuing to share it. Please do continue to do that. It's fantastic to see people share those tips. As I say, sometimes we get tips I didn't even know about in teaching this, as we found earlier. So yeah, please do continue to share that. Okay, let me share my screen again as we move into the final exercise for today. So we've actually covered quite a lot of stuff today, actually. So we've covered functions first thing this morning, and then we did a bit of exception handling, and then we looked at a bit of file handling, particularly with CSVs, but looking at how you would handle files generally, but using the CSV library in particular. And then we spent a lot of time today really looking at NumPy and Pandas, which are two crucial data science packages when we're dealing with very large scale arrays, which you are going to be doing. So much as in last week, we had a little group coding competition. We are having another group coding competition this afternoon. So in your groups, you're going to go back into your groups. You are going to once again be tasked with designing and building a computer program that can do anything you like, but it should use some or all of the concepts you've learned about today. I think probably using all of them would be a push given the time, but give it your best stab. So you're only going to have about 35 minutes, so you may need to rein in ambitions a little, but see what you can do. Be as creative as possible. Sammy's going to judge the top three, and will award PSG points to the top three. I almost feel like we should award some bonus points for NumPy usage, given it is a bit more difficult, but we'll see what happens. But I'm going to stop talking there. I'm going to put you back into your groups. So have a think about nice little pieces of code. And when we come back at 4:20, each group will have 1 minute, much as last week, to quickly show us what they've done and talk us through it, and we'll be tight with time as well. And then Sammy will judge the top three. So let me stop sharing and go and create some code. Hi everyone. Okay, so welcome back. I think I got around to all the rooms, and some really interesting ideas coming out here. I appreciate you didn't have very long to do this. And you were doing some more, using some more complex structures. So, Sammy will take that into account when she's judging this. But we're going to go through the rooms now. We'll do it in reverse order, I think, this time, just to make it fair. So we're going to start off with Zilog. So you'll have 1 minute, and I will cut you off if you go over. I'm just bringing up my my stopwatch. And 1 minute to share your screen and talk us through what you've done, or at least what you were trying to do.
Hello. So let me quickly share my screen. Okay. So our idea is that you have we've got this CSV of recipes, and we'd like to have this program where the user can put in what ingredients they have, and it will filter the data frame to only return the rows that they can basically have the ingredients that they can physically make that kind of product. So you literally just up here, it will ask you with a load of, just ask you to enter each of the amounts, and it will try and convert that to an integer. And if it doesn't, it will hit up this exception. It would be better if we put these individually into try an exception, so that if one failed, obviously the whole thing wouldn't fail. We have some other things as well where we wanted to put like each one of these things, we just like scale them up by ratio to put them into NumPy, like explore that as an array. We thought that'd be a really good idea, but we ran out of time. I'm not going to try and put some ingredients in because I literally can't see where the things come up on my screen. But that's the idea.
But no, thank you. No, I've got the gist of that. What a fascinating little app! I think that I could see that being really useful. So hopefully you'll finish development of that one. Fantastic. Thank you very much. Okay, that was Zilog. So TIA, you're up next.
Hello, can you hear me and see my screen?
Yeah.
Fantastic. So we're doing this. This is sort of I'm going to call this a human learning endeavor, because we're going to try and get better at predicting whether people survive the Titanic or not. So if I start this, it's trying to import the file. It's found it, and that's why it's telling us we're king of the world. It's giving us a nice little boat here. And it's also giving us our odds. We've only got a 38% chance of picking a survivor if we choose that someone survived. And we've now got Mrs. Hocking here was in class 2. Did they survive? I'm going to say no, she didn't. No, she did, unfortunately. So I was wrong. And if I'd got it right, I'd have got this 23 that she paid for her ticket into my score. But my current score is 0. Let's play again. Now we've got Miss Petterson. Did they survive? Let's say they did. Doing very well so far. Same thing again. Let's try and hit one where I do get one right. No, no good. This one's not refreshed properly. It happens from time to time. Hit an R, then it will, an exception will pick up that it doesn't know what they said, but I can now see this row because it didn't print in time, and now I can see.
I'll have to stop you, I'm afraid. You're out of time, but
I didn't even get one right.
Never mind. Well, it was indeed a fascinating insight into some sort of weird wagering on the death of Titanic passengers. So it was certainly a very interesting idea. So thank you for that. Fantastic. Okay, Sid, you're up next.
Sorry, I'm just looking for the share button. I'm here. Hopefully you can see that.
It's coming through. Yeah, there you go.
Yeah. So yeah, we've also gone for the Titanic theme. Ours is maybe less of a game, more of an information system. So in our one, it asks you what your name is. So you're trying to look for passengers with the same name as you. And so I'm gonna put my name in, and there was a passenger with the name Ruth, and the passenger survived. But if there wasn't, then it'll, I don't know. I mean, there probably was a Fred, to be fair. Yeah. Anyway, so the next thing we've got find a passenger with an age that we're interested in. So we can look up was there a passenger who was 19 years old, and it'll print off information about all the different passengers with that age and whether they survived. And we've also got some exception handling here. So if I put a name here rather than an age, it'll tell me that that's not a number, and I need to put an actual age in. And yeah, so there were no passengers who were 100 years old. Yeah, so that's what we've got here.
I think that's brilliant. Yeah, you're out of time, but thank you very much. So yeah, again, really interesting use of the Titanic dataset to extract information. So again, really interesting use of that there. Okay, thank you. Next up is Pokey.
Oh gosh, I don't know if this is even going to work now, but we'll try. So our idea was based on the lightning storms that we had over the weekend. So we've got some user inputs of how large of an area you want in square miles. And this iterates through this while statement. So we've got some X coordinates, some Y coordinates, and some time. So we've got 365 days. And basically inputs stuff into the array and then tells us how long it takes for lightning to strike twice at the same place and how many days. So we can have a big area for it to do so. We've got 500 square miles. We're done. Something's not working here. Sorry, I was trying to put some ASCII art in and went back. Oh, this is embarrassing. Well, beforehand, it did tell you how many you talk to just like in the same place at once. And if you had a larger area, it took a lot longer, obviously, because there's a lot more arrays to read through. What was your thoughts today? Because
You've broken up there, but you're out of time. But no, thank you anyway. So I think we got the gist of the idea. Anyway, and I think somebody's posted in the chat. I think you just got a small indentation error. That's all that is. So that should be working. And I did see it working in your when I dropped into your group just before we came back. So really interesting idea. Yeah, I hadn't even considered that. So a nice use of NumPy there. So well done on being brave and using NumPy. I like that. Fantastic. Thank you. Okay, Paula, you're up next.
We need to be able to share the screen.
well, I'm going to talk and Maya's going to share. So.
But whoever's sharing the screen needs to stop, otherwise we can't start.
Yeah, sorry. Whoever was sharing before, can you stop sharing your screen? You're still sharing, by the way. That's it. Thank you.
Cool. I'll start sharing, and Heath's gonna talk us through it.
Thank you.
Okay, so we went down the morbid route, as a few people seem to have. And we were going to look at calculating your chance of dying if you were on the Titanic based on certain criteria. We did have the idea of actually using NumPy to actually do some sort of bit more complex calculations on this, but we just didn't think we had the time to do that. So basically, you just put in some criteria based on age, sex, and how many children, how many siblings you've got, and it will spit out what your chance of dying was.
So this was working a second ago. Let me just, oh yeah, sorry. No, it'll work. Okay.
Now we're running.
You have an 8% chance of dying.
So not bad.
Fantastic.
Bit more, but we could have had a chance of surviving, really, couldn't we?
Yeah, nice. But you know, to be fair, any analysis you do of the Titanic data is going to be morbid slightly. So, but yeah, no. Again, really interesting use of the Titanic data set, and of course, you're effectively going to be doing exactly this, but using machine learning algorithms in just a couple of months' time. So, fantastic. Thank you very much. So that was Paula. So Motorola.
Okay. Can you see?
Yep, that's all come through.
Okay, yeah, we spent quite a lot of time. We created a data set and spent quite a lot of time trying to then find it to get the program to connect to it. So we didn't have very much time for programming, but it was meant to be a guessing game about pandas and where they were and what they ate. So all we managed to actually code is to kind of get the CSV in and then work out which of the pandas ate cream teas. But the idea was that you could give a list of all the pandas' names and people would guess, and we would do a if they were correct kind of guessing game.
Excellent. Thank you. So almost like a guess who of pandas.
Yeah.
Fascinating idea. Thank you. I really like that. Brilliant. No, and you know, I think probably a good lesson for your projects. You will end up spending a lot of time doing all the stuff that you don't expect to do at the start, to just try and locate things and get data and all that kind of nonsense. Unfortunately, that does often eat the time. Thank you very much. Okay, so Denise.
Yeah. So hopefully everyone can see that.
Yep, that's come through.
We decided to make a kind of personalized BMI and cardiovascular risk calculator. So we kind of made our own CSV file, and then we're just working on basically the premise was that you're going to be able to input your height, weight, gender, age, and then it would give you a risk profile of your risk of cardiovascular disease and diabetes based on our made up data set, and give you your BMI
give you a little message saying, oops, you're underweight, overweight, or healthy, and then give you a little personalized piece of artwork saying different pieces of exercise that you could do, or if you were underweight, maybe showing somebody who's just asleep. And that's basically as far as we'd got.
Excellent. No, thank you. Again, really interesting idea. Love the ASCII art, as many of these have shown. And I have to say, yeah, pretty impressive the amount you've managed to code there in what was effectively half an hour. So so well done. Again, amazing what you've all managed to come up with in that short space of time. Okay, so nearly there. So Arm is up next.
Hello, everyone. Let me just share my screen. Okay, so can everyone see that?
Yep.
Our idea was to have a tool that helps you pick what you're going to watch from a IMDb database. And we had to do some coding to remove some corruption of the release year, because everyone's favorite release year is obviously PG. So now if we run it, fingers crossed, it will start asking you some questions about what you would like to watch. So how much time do you have? 120 minutes. Because I haven't put 1,000 and it's not going to come up with the actual Titanic movie. What genre you'd like, and what decade the film should be from. So I put 1970s. And then it will come up here saying 1970s. I think you meant the 80s, and then it will suggest a film to you. If you're looking at the code, you may realize it doesn't actually care what you wrote. It just gives you a film from the 80s, but that's because that's what we should be watching anyway. So.
I quite agree, and clearly, there's you know, you've won this. If only I were judging, but alas, you've got Sammy. But no, really interesting use of that. Liked the way you linked out to the IMDb dataset. Really nice, and yes, a great little twist at the end there. So last two, Antic.
I think you're on mute.
Hello, our idea was to create a ice cream van of a shop. We didn't finish the coding. So the basic idea was we would import some kind of CSV file for a new list of ice cream, but since we didn't have that, we created a dictionary, turned that into the data frame using pandas, and then inserted a new random number of stock of ice creams within our van, and then create a function to define the ice cream van transaction with the customer's choices, how much money they have, and the number of ice creams they would like to have. And then based on the number of the ice cream choice, they will give the cost back, and using that to calculate the total cost of the ice cream, then taking the calculation of the transaction of how much money is needed and how much is total cost. If the cost is negative, we tell them that unfortunately you are short in money, or else we thank them, and then using try except function for any of the values that are incorrect input, such as if it's not a integer or float value, then return error and tell them to insert the right number. And then we print out at the very end.
I have to cut you off, but thank you. I got the gist of that. Again, really creative idea that you put forward there. I'm loving the diversity of ideas. We've got everything from ice creams to Guess Who with pandas to effectively robbing money off dead corpses on the Titanic. I don't know what to expect as we go to the very final group. So hang on, that was you. Was that you Arm or Antic? I can't remember what I'm doing now.
Antic.
You're Antic. Okay, yes. So it is the final group. So Agnes is up last.
Okay. So we have used NumPy to play bingo. So I'll just start the game. So it prints us out a little bingo square and asks if we're ready to play. So I'll put in yes. So it calls out the number 1 that appears on our card. So it replaces it with a 0, and it's going to keep doing this until we've got all zeros. So there we go. Which hopefully should happen because we're not making this very difficult for ourselves. Normally happens a bit quicker. And then it should say bingo, hopefully. And obviously we should have done a bit of exception handling here. Whoops. And we should, because actually I can type anything in here and it will still accept it. I don't know why this game isn't finishing now. There we go. There we go. It's done. Amongst other things. And we're going to make this competitive, and we're obviously going to make it more difficult and not just use numbers between 1 and 10. Those were ideas for the future.
Fantastic. Thank you very much. Will, you really didn't want to give you a 6 on that last
It
one.
really didn't want to give me a 6. That was inconvenient.
Fantastic. Again, really interesting use. And let's face it, who wouldn't want to play bingo using NumPy after today? I'm sure that was your first thought on all your minds.
It's the most mathematically complex of all the games.
Absolutely, yes. Fantastic, thank you. Okay, well, again, sort of 10 brilliant submissions there, all really good. And I have to say, considering you had basically half an hour to come up with that, which is half the time you had last week, I think amazing that you've come up with those ideas, particularly around more complex subjects as well. I can't wait to see what you all come up with when you have some of the longer sessions as we go through, where you'll have this kind of activity to design stuff and build stuff. In fact, in one session you can have 3 hours to do this, to do something like this. So I can't wait to see what comes out if this is what is half an hour. But I'm going to hand over to Sammy now, who's going to give us her deliberations and tell us who finished on the podium for this particular exercise. So over to Sammy.
Thanks, Dan. I'm finding it harder and harder to make decisions on these. I'm really impressed with, as you say, what you've managed to do in 30 minutes, and so impressed that unfortunately I've got 1 gold, 2 bronze and 2 silver. I haven't managed to narrow it down any more than that. So I will start with the bronze, if that's okay. Pokey and Paula, I've put you both in bronze position. Pokey, well done for giving a go at NumPy. I really liked what you were aiming for, and your demo was so close to working. I couldn't not reward the use of NumPy. Paula, bronze, I thought you did. I loved your idea. I thought that was fantastic, and really well executed. I'm going to put Arm and Agnes both getting silver. Again, Agnes, your use of NumPy, and I loved it, was a really creative and novel use of NumPy for what you did. And Arm, really like to see you using a new data set, like you using the sample function from Pandas, and nice use of all your try except. And in gold, I'm going to put TIA. I thought that was a really nice game that you put together. Great to see try except again, score tracking, etc. You got a lot done. So excellent. I'm just loving the celebration as well. I just saw a brief video pop up.
Brilliant. No, thank you. So am I right in saying TIA was the one that was effectively robbing money from dead corpses? Is that the one?
Yeah, that was that one. Yeah.
Okay. Now know the way to get to Sammy's heart here. The more morbid, the better. So well done to TIA. But yeah, no, great work, everyone. I agree. I think they were really creative, really nice applications of the things you learned today. So well done to you all, and a special well done to our podium entries and to TIA for their excellent entry coming in first. So well done, 15, 10 and 5 PSG points for those podium places. Fantastic, thank you. Okay, so apologies, we've slightly overrun again. It was just too good to not hear about some of those presentations. So fantastic, well done, everyone. I have to say, massive well done to you all. I know this is a lot of information you are taking in. We weren't kidding when we said this course is intense. It really does, sort of ramp up. But you are all doing exceptionally well, genuinely. Just keep thinking. This time last week, you'd only just learnt how to print the words "Hello World" to the screen, and now you're working with multi-dimensional arrays. I think that's quite a jump. And this is, as I mentioned earlier, something that people who code struggle with things like NumPy. So you're doing really well picking up all this. Next week with the final of the Python tutorial sessions, although your Python learning will continue for the next 6 months. But in terms of kind of the basics intro sessions before we get stuck into some of the methods. So next week we're going to talk about things like object-oriented programming, and we're going to look at matplotlib, which is a beautiful and really easy to use, you'll be delighted to hear, package for plotting graphs, really nice graphs. And we're also going to talk about debugging as well, and the one of the exercises next week will be Dan's Devious Debugging Challenge, where I've deliberately caused a lot of errors in a piece of code and you've got to try and fix them, which is always popular in inverted commas. So I hope you look forward to that. Keep practicing away, keep plugging away, even if it's just, you know, finding 5 minutes spare just to write 2 lines of Python code. Believe me, it will make such a difference. Just keep practicing with those skills. But don't worry if this is coming more slowly to you. That's completely normal as well. You've got plenty of opportunity to keep practicing these things over the next 6 months. So I just want to reiterate, you don't have to get to the end of next week and think you have to have Python licked. That's not how this works. So lots more opportunities. And indeed, as we go on, you'll find that the methods we teach you are quite structured, and you'll be able to learn how these various methods are structured in their particular ways, and learn those frameworks. So that will help, I'm sure, as well. Also, just to flag up, there is that Sammy is putting on the first of our revision sessions next Wednesday, which will be the day after the final Python training. There'll be a revision session for every module. It's completely optional, but if you have been struggling with that, it may be worth coming along or trying to come along to some or all of that. Sammy, I don't know if you want to just say anything about that or any plans you've got for that.
Yep, so it's still being finalised, but so I will try and put out a bit of a schedule, just so if there is, perhaps if you found week 1 easier than week 2, you might be able to come along just for a chunk of it. But we'll be going really slowly. We'll be going back over everything. There will be a chance to ask as many questions as you want, and yeah, I thoroughly recommend coming along if you can, but if not, I will try and record as much as possible, so that we can people can refer back to it.
Yeah, brilliant. Thank you, Sammy. And yeah, one key thing to say there, please, if you come along to those sessions, or even if you don't and you've just got questions, there are no stupid questions. So even if you think you should have understood something, please ask that question, because I can guarantee other people will have that question. Even if they don't, it's important that you feel that you can answer that. So there are no stupid questions at all in HSMA. So please ask away. Okay, thank you, everyone. Thank you for coming along today. I hope you've enjoyed it. Next week, it's all about the object-oriented programming, matplotlib, and debugging. So look forward to that. I'll see you in a week's time. See you, everyone.